GPU community second meetup. And this time we are speaking on computer vision here. I would like to welcome Steve guest and all the participants. Thank you so much for sharing your time and knowledge with us. Okay, to officially welcome you guys, I would like to welcome our CPO and founder, Mr. Gaurav Tripathi. He is IT Bombay alumni and he has 45 plus patents. He has started multiple startups. Innoplexus being his first one. And you can have any kind of discussion with this guy from tech to like spirituality. That's like I had all of them with him. So yeah, please welcome Mr. Gaurav Tripathi on stage.
Thanks, Arash. Very warm welcome to all of you. And we have started late. Apologies for that. But I guess we were waiting for more people to turn up. 130 people registered, and my team was very happy, thinking that yeah, we'll have at least 80 people coming in. Yeah, so yeah, that's not how things turn out. And but another thing is there are people on the way. Unfortunately, people still operate. I hate to say that Indian standard time. Yeah, a lot of people are actually coming late. So the time was poor, but people are coming. So yeah, we have more people. But thank you to all of you for being on time. At least that is what really makes my day. So we started this community with the sole aim of bringing awareness around this topic. So the topic of GPUs, and we ourselves, we have been working with GPUs for I think more than 7 years now. I personally, I have been working with GPUs since 2004. Although at that time it was more related to gaming than anything. I used to remember all the latest models and whatever the differences between the different graphics cards supplied by Nvidia, because those were prized assets for gamers. Yeah. But yeah, now all of the progress that we see in AI in the last decade, it has been largely possible because of GPUs, and Nvidia as a company has been driving the innovation on that. Had it not for GPUs, we would not have seen such a progress in such a short span of time. ChatGPT would not have been possible if not for GPUs. Really. So yeah, GPUs are really important, and that's where we see that overall. In Bharat itself, the awareness is quite low. And in Pune, when we became a media partners long back, and when we told NVIDIA we want to buy those NVIDIA supercomputers, the DGX 100 and so on, they were really initially puzzled. Who is this company coming out of Pune who wants to buy something? Do they not know the price? Right? But yeah, that's how it is doing. And even now, we don't find that many takers for GPUs, right? So that's the idea behind having this community, that we drive it to the point why it is important, how it is important, what are the use cases where GPUs have been used and where it should be used. That's been the core idea, and having a community around where we can learn from each other, we can share use cases, we can share learnings, and have a good community growing up in Pune, wherein someday we'll be able to say, yeah, I've always said this earlier that क्रांति की शुरुआत पुणे से ही हुई है. Whatever kind of revolutions we see in our journey in the last 400 years, as we see, a lot of things actually started in Pune. So maybe this as well starts in Pune. That's our attempt. So that I again welcome all of you. We have some really wonderful sessions by very esteemed speakers. The work that they are going to present will really leave you amazed that this is what is being done. And I hope that from those use cases and from whatever we discuss here, you will also have some takeaways. Thank you.
Thank you, Gaurav. For the first session, I would like to invite Ajit. He is my dear friend. He is an IT engineer. He has 7 years experience and he's leading the AI and data science team at Innoplexus. Welcome. Please say his audience.
Hello. Hi. Thanks, others. Hello all. Thank you for taking up the time. So, I think this slide. Um, I think this session is mainly, this is kept in the first session is basically why, because we want to know what computer vision is. So, the slide, the motive behind this presentation in the first part is, in a very non-technical way, can we understand computer vision? So, okay. Okay. Sorry about that. So, with that, let's go about the agenda. So, what we are trying to do here. So, first, we'll be understanding like what actually computer vision is. Then we will move over to few evolutions of how computer vision in the past decades has emerged. The main part of the session in which the main focus was how the computer vision works, I will be trying to explain and in a very non-technical way. So there are few complaints in my past sessions that I does into very technical things. So please ensure that if I go into technical, you raise your hand and let me know that this is very and the fourth part is basically, though there are stream speakers who will be speaking about the application, but I will be giving you a very brief idea about the different area of applications where the computer vision can be applied. Okay, with that, let's start. And the first question: how humans see, how we as a human see, and enjoy others. So it's simple question, simple answer. Okay, so correct, bingo. We see through our eyes. And it's not just eyes. Eyes is just a part which allows light, and then receptors are there which access it, and there are but visual cortex which process. That's what we are saying. So this whole combination is actually like this whole combination actually helps us to see and understand the area around us, understand the visuals around us. So there was in the early days of computer, there was an experiment in which there was a box and there was a simple a foil in it in which there was silver chloride and there was a slit in it. And what the researchers do is they open the slit and the light falls in the silver chloride. Wherever the light falls in, it darkens, and in all the other areas, it doesn't. So it gives you a brief outline of what the actual current visual it sees through the slit. But is that sufficient? So just seeing that what is around. Just seeing what is around, will that sufficient? Or do you want actually what actually there is? So if you see this, there is a bowl which of fruits, and when you see it, we want to know that there are different. There is a bowl, there are oranges, there are lemons, there are peaches. So there are different kinds of fruits out there. It's not just that we see this picture and nothing. We need to process it. In a very similar fashion, the computer vision system works. Sees the ball through some instruments, sensor system, it has an infrared device, and then it gives you a very similar job of ball or it is on this level. And this is what computer vision is. Basically, it is the field in artificial intelligence that enables machine to interpret and understand the visual information from the world. You see, whatever it sees, it's not just that it sees around as a visual information around us, but it also knows that what actually is there in that scenario or in that visual information. Next part, basically the evaluation. So, in evaluation, as I said, the first experiment was the black box experiment in which they gave languages. But around 1950s and 1960s, there were researchers who use a cat and they have all the wires connected to his brain and they were trying to see what actually excites the brain and what was the visual information that they see when the neurons get excited. They found that whenever the cat sees something which have edges and all, few parts of the neuron get excited. And similarly, when it sees an image which is very similar to the food or fish kind of thing, it gets very happy. And again, in the same era, there was a version of perceptron. It was simplest form of neural network that was discovered at that time, and that is one of the kind of starting point in which the researcher starts to think about computer vision. Then comes, once they were able to capture information, they were able to access it. Then comes the part of detecting edges and the features on it. And at that era, one of the important detector that were identified was candidate detectors and hue transformations. The candidate detector is something that has the ability, that is one of the filter, that has the ability to detect edges. And similarly, the hue transformation is a part where it is able to understand the image as a whole and it get to know that what actually is there in the mood. Fast forward to another 10 years, and we have object recognition, that what actually is the object. But the major discovery that happened was the deep learning evolution. I think many of us know there is a challenge that happens every year, and it is called ImageNet Large Scale Visual Recognition Challenge. And it is the year, that year only in 2000 around 4, where the AlexNet was introduced by one of the great researchers from Google. And why it is great? Because before that, there was no model which were able to achieve a level of accuracy that human can achieve. So if you give a set of images and you ask human to classify them, let's say I give you a very basic example. Say I give you another example, and before that, it was able to do 80s in 80s correct classification. But at that point of interval, it was surpassing the human adaptation. Basically, even if the human were not able to classify whether which class or which object it is present in the image, but the machine were able to find it. And then comes the advancement in the deep learning part. In the deep learning, one of the advancement was the use of the transfer learning. Basically, data is always a problem, tag data. So transfer learning is one of the technique in which you use a model which has created a different set of information, but you can using a very small amount of data, you can transfer the learning, you can use the learning, and you can use the same model in your custom data sets. The other discovery was GPUs and GPUs. Once the GPU was there, And it were there, we were able to do multiple rounds of experiments. We were able to train our models in large amount of data. Previously it was nearly in thousands, but after this GPU, you can say that it can be 10,000, 50,000 in numbers. And nowadays it's even crossing lakhs. So thanks to all the GPUs. Currently, you can see there are large vision models. I think everybody is aware of DALI and Mistral and these things, or there are models like Lava. So these are the different large vision models that are very capable of understanding the different scenario and able to make it what the overall scenario is about. Okay, another question. So, as a human, we can say it's a flower, right? What do you think of these seeds? Flower or something else? Patterns, pixels. It's actually numbers, pixels. Actually, the pattern comes after that. It goes into all the fish engine part and then it recognizes some pattern. So the first thing that it sees is just numbers. These are numbers, pixel numbers. I think if I ask you, if I have not given you this and if I ask you this, you will not be able to say that this is a picture of flower, right? But if I give this number to the machine, it will be easily able to tell us that it's a picture of flower. So that's what machine sees. And then comes the next part, in which that's another question also. So I think everybody must have seen that this animal, this is a koala. If I say this is a koala, then why I'm saying this is a koala, right? How or actually how you will be able to tell if this is a koala? Can anyone tell us? Or even if there was some elephant or some giraffe or anything, how a person can tell that this is an elephant, this is a giraffe? In this case, this is koala. Any guesses? No? Everyone should know because it's very basic. Yeah, please go. Multiple times, same data, same data. It might happen that you must have not seen this picture, but you will still able to recognize that this is koala. It might happen that you have not seen this in the past, or if there is giraffe, they are not the exact giraffe. But you will be able to recognize that it's a giraffe. Why is that? What? Yes, please.
Some unique characteristics or properties.
Characteristics, properties, yes. What kind of characteristics did I ask?
Like they have a lot of height of the neck, or face.
Face, right. So basically, when we say it's a face, what we actually see? Eyes, nose, mouth, right. In a very simple fashion, we are able to tell it's a koala because we can see these kind of characteristics. There is an eyes, it has koala-related eyes, yes. It's koala-related nose, yes. Ears, yes. Hands, yes. So there is so these all calculations, these all conditions happens in our neurons. Basically, neurons are trained in such a way that it is able to recognize in few neurons were able to get trigger when it sees this part, the eyes. Then it sees when it sees the nose, few of the other neurons get triggers. And similarly, there are some neurons which collates all this information of ears, eyes, nose, ears, and it is able to say that this is a koala's head. And similarly, few of the neurons collate this and it says koala's body, and then at the end, our brain is able to process that there is a koala head and there is koala body, so it is a koala. Here, so let's take a simple example. I think everybody is able to recognize numbers. Similar to what we have recognized, similar to how we have recognized cola, we are able to recognize the line also, right? How we are able to see that there are these kind of features, circle features, which ultimately goes and forms loopy circle. Then there are images, there are features which gives to the vertical line, there are edges which goes and form the diagonal lines. And then when all our brain processes information that these three are features kind of presence, then we get to know that this is the number 9, right? So what are these features actually? So basically we are able to, in this case, our brain is able to process that. There is a loopy circle, there is a vertical line, there is a diagonal line, right? But how does computer see it? Computer is able to extract a very similar kind of information through filters. So to detect loopy filters, to detect loops basically, it can use this kind of filter. To detect vertical lines, it can use this kind of filters, and to detect diagonal lines, it can use this kind of filter. You can see 1, 1, 1 here. For loops, it is 1, 1, 1 here. And these filters are mainly applied on these pictures, right? Now, it's not that, so what is the symbol? Basically, the symbol is basically convolution. Basically, this 3 by 3 filters is applied to all over the images, so that wherever it detects a loopy circle, it says 1. And then, wherever it says vertical, it says 1, and similarly for diagonal. And when all these features combine, it gives me that these all 3 features are there, and if these all 3 features are there, what it is a number 9. It's the similar logic to call a picture. Similar kind of filter we can apply in the images. If there is an eye, if there is an eye present in it, if there is a nose present in it, if there is an ear present in it, if we mark all those areas, it will combine all, and it will have a set of filters which will detect that if there is a nose, ears, and eyes are there, then we can use that's the head, yes. And then similarly for the body, it gives you hand and legs, and gives you that yes, there is body. On top of this, now you have in a very similar fashion in which the human has extracted the features. Similarly, we have now the features. You can simply apply a neural network, fully connected neural network. This is nothing, but you have these features, and then you give it to a set of neural networks. Why this is there? Because it might happen that tomorrow the picture you will not be able to see the same picture, right? But you will be able to see a different picture. In that picture, using these filters, you will be able to identify where are the hands, ears, nose, legs are present. But you need to know that you need to make a model learn that if these are present in such pattern, then it's koala. That is what this fully connected layer will do. So if you take another picture, a similar kind of filters will be applied, and a very similar features will be extracted, and then you will have a network which knows if these patterns occurs, it is a correlation. All the steps that I just said, extraction of features, extraction of different features like nose, ears, eyes, and then understanding the features and then classifying it. This all actually is done by convolution neural network, CNN. Many of you have heard. This is one of the breakthrough or one of the foundation, I will say, model in computer vision, which has till date has able to replicate what exactly the human does to understand any vision around itself. So in very similar fashion, the convolution network, the filters that I just talked about, this is exactly done in the convolution layer. The rainbow is basically it's a step. It's a step to bring non-linearity. And I say non-linearity is simply you can understand it basically simple A to A. Okay, simple direct relation will not be there. A more complex relation will be there. To capture the complex relation, you introduce non-linearity in the network, and that is why it comes in the picture. And then comes the pulling layer. Pulling layer what is there? It is there to the first thing, the primary function of pulling layer is basically it gives you it filters out the most important features from your layer. So basically, it might happen that there are some noise around your picture, right? But still there is something nice is there. So pulling layer is one of the things that it reduces the noise, but and it will give you that there is an eye that is there. And it also helps us to decrease the complexity of over all the networks. And similarly, in CNN, there are multiple layers, multiple repetitions of these convolutions and pulling layers, and then the final classification layer that is fully connected layer, and that is what gives you the convolution network. So next step is basically once now that we have understood how machine works, how machine sees, the part is where it applies. I understand that how computer sees, I understand that how computer works, but क्या फायदा है इसका, right? So these are the failures. So there are, I think, speaker will be telling us about healthcare domain, in which in one of our use cases related to medical imaging. There are different use cases like pathology, in which they try to detect the cancer, there is cancer in the radio image or not, and there is dermatologists to understand if there is something unusual in the skin, is it cancer or not. Then there is ADAS system. I think ADAS is very well will be known by you because I think Mahindra is like SUV 700. It has this ADAS system. So it's nothing but it's automatic driving assistance system, which is able to capture the information around you and is able to tell you what should you do, what it tell you actually tells you. Do you go left? You should go left, or you should go right, or because it should assist you in your driving. Then there is an application in the retail e-commerce. There might be you have seen that there are like you go to the market, you just buy it, you scan it, and there is no person that who will be billing you. You have to do, you can do self-billing yourself. This is all possible because of computers. There are different cases like manufacturing industries and agriculture, manufacturing industries. You will say the repetitive tasks that are done in the manufacturing, like acquiring all the in the in the warehouses, there are activities like you stack all the orders, you drive all the orders. If there is if it's order X, then you have to go left. If it's order Y, you have to go right. So similar kind of scenarios. It's been handled in the manufacturing industry. In agriculture, this is one of the very promising. There is like you can click a picture of the plant and it tell you if there is any problem with the plant or not and what can be done to make it better. I think with this, I'd like to end this and open it for any questions if you have.
If giraffe is to be identified as giraffe, so the number of input images you are giving it to the for training of the model.
I repeat, if giraffe is to be identified as giraffe, so what is the most important factor? Is it the number of images which you are giving to the training model? Is it the number of pulling there? Or what is this?
The first thing is basically the number of training data, that is images that you will be giving, and the quality of that training. If you have if you have 1,000 good quality images, it will be equivalent of 10,000 bad quality images. So the first thing is definitely you should have a good number of images. The second is basically this pooling layer, this feature extraction. So yes, thank you. One thing I missed here is basically, if you say this, when I say that the features are ear, nose, and head and everything, these features are not handmade features. If you take convolution neural network, you just have to give it sample, you just have to give it tag data, you just have to give it that for the time being, let's take 32 32 filters and take 10 pooling layers and so on. And using that tag data, it will reiterate itself multiple times. Like it will take the first image, it will do all the forward thing, it will try to predict, it will definitely predict first and wrong, and then that wrong prediction will then back propagate. And it will update all the features values that are present in the filters, and with this repetitive task of forward and backward, it will automatically learn what kind of features I should pick there so that it will be able to identify giraffe for all the next iterations of the photos. So it should automatically learn all those different kind of features. So these ear, nose, and all these are very like for just for illustration. Actually, these are not the features that the organization will use. But it will automatically able to derive from the tag data what kind of features should be there to actually identify that visible now. So pulling layers and everything, you are like kind you can repeatedly change over the time. You can keep on saying that, or you can use grid search algorithms and different kinds of algorithms to tune that. But those are like external factors that will matter. But the main thing that will matter is basically the training image that will be. Now that answers. Any else? Any questions?
Arpan, maybe you can just touch upon what do we mean by quality data? What is it that it should have? Right? Otherwise, they are fine. I mean, how do I even know that I have got 1,000 images? In other set, I have got 10,000 images. It is better. What should I look for when I'm building a training data set?
That's a good point. So, whenever I say a quality image, it should be in an ideal world. It should be crisp clear, it should have very good definitions, or it should have very defined boundaries of that image, of that class that we are trying to identify. It should have various different, like lots of variations of that giraffe. So if I take the example of giraffe, it should not just have a single pose of that giraffe, but the picture should be taken from multiple angles, in multiple scenarios, in multiple environment. That will help the model to learn the different cases that it can encounter in future. It will be able to learn in a very generic manner in that way if you have that kind of variations in the model. So variations, good quality images are two things that you should be taking care of in the data. Yes, please.
I'm a surgeon. I see a lot of problems with this approach to medical images being processed by machines. The first problem is many of the images do not correlate with the suffering of the person. And that knowledge is never taken up by machines. And second problem, which is practical every day, is most of these images which are read by people or machines or algorithms, whatever, you come out with a report of that reading, which is given to the patient under the pretext of sort of empowering the patient. And we have a huge issue where patients start arguing with us that that person told me that this is the problem. And why do you say that this is not the problem? They don't know that there are 30% images which do not correlate with the suffering of the person. And that aspect is never talked about in your discussions. I fail to understand. You see, you spend so much time, energy, money, efforts, but human suffering cannot be understood by images alone. There has to be a samvedana. Unless that is there, all this is good talk, all this is very good, this is very impressive. But ultimately, when a decision has to be made, I normally ask the patient, would you like to get operated by the loco or by me? You
That's a great point. Okay. Okay, please go ahead.
So that's a debatable questions and everywhere is going on. And the research and whatever the progress going on in computer vision is to not to validate these results, actually to improving or helping them for the better decision makers. It's not to override their decisions. So this is what our aim of the research is.
Yeah, I think one of the point that Hunter says is mainly covered. Is basically all this development. Definitely, the question that you asked that is it.
I'm actually not jumping on that because we are going to cover that part once we
That's it, okay.
once we cover the session, then we part of the answers will be there.
So you're putting me on the spot.
Okay, so I will just say that I will cover the session, and from my point, the main technology is basically to assist you, to help you to take better decisions. It's not a debate that it's a replace, I would say, but it's definitely there to assist you and to make decisions much more better.
Any other questions for Arpan? Please go ahead.
Hello, sir. So my question to you is, there are a lot of algorithms out there, like vision transformer and Relive. So, how do you know that what algorithm to choose? Is it about the trial and error or some other process?
Good point. Good question. So, this is just first of all, this is just an introduction, so I cannot cover that point. But what I like to say is, if you know the architecture, if you know the limitations of the model, if you know the pros and cons of the model, how it is being developed, what are actually the scenarios that it can cover, or what actually is the process inside that model, then you will be able to make that decision. You cannot make that decision just by hit and try. It will take you months, I would say, because the data, size of data is huge. Number of models these days is huge. You cannot use every model, you cannot do anything. The only thing that you can do from your side is to understand the architecture of the model. If you know the architecture, you will definitely be able to know that which model will be used when. Okay.
One more question. You have mentioned about the 2D and 3D thing about the image.
Okay, I try to keep it simple, but I see that I should have made it more complicated. If I see here, this part, this is not a 2D extraction of the feature, this is 3D feature extraction. And this image is actually not 1D, it's not grayscale, 0 or 1. It's basically combination of 3 RGB. So it's actually, if you take a full HD image, this is 1980 cross 1080 cross 3, that's 2 times.
If I can have a follow-up question on that, what do you mean by 3D image? Are you talking about 3D models or something?
You see, we do CT scanner and all.
Yes.
And we get a printout of those images, which
Yes.
are 2D.
Yes.
Then we get a machine-created three-dimensional sort of reconstruction,
Yes.
which is very close to the human structure.
Right.
And we try to plan our surgery by looking at those images, which we try to maneuver, etc.
Right.
What we feel as doctors is that the 3D visualization capacity is in the brain and not in the patient.
Okay, right.
But that point, many times, is a point of discussion, where the gadget people always say, no, no, the gadget can give you three dimensions, which we personally don't agree. But whatever you show in front of me, I won't be able to understand unless my brain is trained to understand.
Right.
Right? And I would say here that seeing is a traveling form. They're not only seeing, they're visualizing.
Right.
There are meaning behind it.
Right.
So that
Yeah.
will change.
Yeah, so I think for that there are solutions available. And I mean, you can, for example, right now VR technologies are allowing you to, VR headset and you can actually be in the brain of something. And you can, visualize it properly. You can visualize whatever has been generated by the machines, but you can visualize, better.
No, we use VR technology.
Okay.
Where you are completely cut off from the reference around in any of those cases. So the problem is the human brain is not able to process those things so fast. Many people get giddy. They feel they are
Right, right.
If you have to have something outside, it should make you feel that this is in relation with that, etc.
Yeah, to that I agree completely.
Now the main question here, if we talk about VR, etc.,
Yes.
is why do all this when you can train the human beings to be better?
Everybody cannot be a doctor. I mean that because I mean it takes what it takes to be a doctor, right? And we know that every one of us cannot be a doctor. So I think that is all we can do is like man was mentioned is to provide a very good decision support system. So that if you are doing like 100 patients a day, then you should be able to do it 250 per day. That is what the aim is, rather than to replace doctor by technology. Okay.
Others, I think it's the high time to have the speakers say their topics.
Right. Okay. So thank you so much, Arpan, for this insightful session.
And thank you for listening and thank you for taking the time. And so use this form that you'll ask so much question. That's me. Thank you.
Thank you so much, Arpan. You started with the pixel and you ended with 3D visualized model. I think that's a really great journey. So, okay, next I would like to invite Mr. Ajit Deshpande. He is founder and CEO of Prices.ai. He is a representative of Agarwal. He has 30 plus years of experience. Like, a lot of us are not born when we started working. So, I mean, I don't have a word to mention the skill set that he has acquired in the past 30 years. So, let's just hear it from Mr. Ajit. Sir, please welcome the big round of applause.
Yeah, hi. First of all, thanks for calling me. My name is Ajit Deshpande. I'm founder CEO of Relive Analytics. My domain is in healthcare and application of artificial intelligence. And again, thanks a lot for making it on the weekend. So, in continuation of what previous speaker talked, I'll see the application area next 20-25 minutes. And some of the words it might sound a bit complex for you, like this diagnostic imaging in semi-supervised learning, GenAI, etc. But the GenAI would democratize the entire process of the availability of current tools. And we have already talked about it, like why this revolution is happening. That is because of the underlying platform. GPUs are there maybe around more than 20 years. Supercomputer in the Chinese supercomputer was top ranking that was created almost 10 to 15 years back. So these tools are available, but because of this recent phenomena, now the complete tech world is taken. Yeah, in general, there could be multiple areas as Dr. clearly pointed out, and I would like to, these are some of the indicative areas. There are a few more areas we incurred as a startup. that include the training for the healthcare professional, including the surgeons and doctors, cross-training them, not just the medical students.
And these are more obvious as of today, like the trials, diagnostics, clinical research support, care delivery, and
Chronic care management, early detection, so and so. So from the advent of this technology, yeah. So now coming to this slide looks very busy, right? So I would like to just ask a quick question. This is a wonderful slide. It summarizes semi-supervised learning, GenAI, everything, right? But there is a caveat. You see a logo below this ChatGPT. This is not written by me. This is written by ChatGPT. So I think we all need to think beyond, not what is very obvious. These are all obvious points. They're covered by ChatGPT directly. And now some people did ask me, they are interns and young boys. So if you are not using ChatGPT as of today, you are out of business. So I don't know. And this is more of a stuff in ChatGPT or the new tools invented now. The ChatGPT is regularly used, even the school boys, they have written application to the principal using ChatGPT. So start using it, that is one aspect, generate the code. And another level, what government is people, technologists of the world can tell you about, use the API, put it in your products. There are various levels. So one of the stuff, even this Microsoft and Google, OpenAI, several companies in this race of GenAI.
and they are already using it. And they, now this Microsoft,
They are suggesting this V2 or something. It is more better, superior than others. And it is a small language model, so this collection of large data sets and everything.
so from the technology perspective, slightly just connecting with the previous speaker, I would like to tell you many of this stuff
Did exist from many years, like this CUDA architecture, right? The architecture existed more than 10 years, I guess.
and then a lot of stuff
Above that, in the middle layer, there are open source. The open source is revolutionizing this, and more open source models coming into your handy tool. Then you can focus on the problem statement rather than creating the technology. The technology creators are already created. Now the domain people has to use it.
yeah. So again,
Now coming to this NVIDIA. So NVIDIA, it was again a graphics card company. People played games and fantastic. But then, few years back, a decade back, they declared themselves as an AI company. That was a game changer for sure. And now they have come up with a multiple tool set, tool chain, I would say.
and this is the you can see this 3D Magic and the Mona Cloud API. And so what it's doing is segment everything.
This again is a Microsoft product. It is again something is done by somebody like NVIDIA. There are several people in this game.
And the bottom one is the
Auto 3D stack.
and there are several features.
So this is again we have just referred from the NVIDIA side. Useful for the medical domain.
So now coming to the healthcare, ChatGPT
3.5 is openly available for you. The API and ChatGPT 4 will have more and more in-depth models available.
and this is an example taken from the cardiovascular. So with the advent of AI, what we are trying to do here is we collate all this data, including say
The PATH labs and
the genomics and imaging and drugs and everything.
and are we able to predict or say one problem to solve is early detection of heart disease or maybe post-surgery, how do you track treatment? There are various aspects, and also training is also a big area now coming up for the healthcare professionals. And interestingly, when the ChatGPT was launched, and now also I don't know the exact date on which the training is stopped as of today. I think it's still using 2021 data, if I'm not wrong. Just cross check, but it is not 2023 data, and it doesn't have anything in healthcare, by the way. So you cannot ask like, do I have disease and how can I treat myself? No. All these things are very secretive tools. In that sense, if you are a common user, if you are technologist, this technology is available to you, and there are several challenges when we enter into healthcare domain.
So again, what is this multimodal model side from the now the switching from say NVIDIA to Microsoft to Google. I just want to highlight that all these players do have their unique way of handling stuff, and they compete. Sometimes we feel like this is all open source, the underlying principles are not changing. Then why do I want this all these things like this multimodal here from the medical perspective? Since medical doesn't have much of a video data, the data is mostly, it's not images, they call it imaging data. So the imaging is, say this is chest X-ray and the mammography. So mammography is low intensity X-ray. It starts with only 4 slides, and chest X-ray, maybe chest PA is just 1 slide. So we call it medical, but it is one-dimensional data. CT scan is called two-dimensional data. MRI is called three-dimensional data. So that is the terminology we use in medical domain. And this mammography is for breast cancer screening. And 3D tomosynthesis is an advanced way with which you have multiple slices of taking the images. So all this combining this thing, and the text means what doctor has written as a treatment, pre-treatment, analysis, all these things combined. And now we can claim that large language models that Google is offering you as a service. But don't get confused by many people. When I go to the client, they say, oh, it is already available. Look at Google. They haven't done anything. NVIDIA hasn't done anything. All this thing has to be done. The hard work has to be done by the startups, maybe productizing. Right? So entities will be very problem specific. Very problem specific. So these are the tools available. This one you want to see. This slide. So I think the presentation was going very technical. I could not take much images and videos, but this is one of the stuff Google has given where this the image is spread. And we know this is for bits and bytes, analyze large language models, and we are asking, is there any pleural effusion present? So in the chest X-ray, we are able to find out multiple abnormalities. There could be the opacity, pleural thickening, lung nodules. It's just one question asked, and then we see the results. So again, this is a busy slide, but what I want to tell you is now in hospital sector, you have electronic health records, you have signals, that is ECGs, then you have omics, your genomics data, some kind of graph, so several things, and then you combine that, and then you make something out of it. So that this is the whole idea. When we also start to build such models, right? In the case of COVID and remote care, you might have noticed that many of the doctors are not able to reach out to the patients. Doctor-patient ratio is very skewed, And we have to be, as in Pune, we have luxury of we can talk to doctor, to any top specialist, super specialist, we can again take the appointment right away, even if it is like Sunday, tomorrow I will be able to meet that person. In other countries, it is impossible, we cannot. To go 20 to 30 kilometers away from the city center, one doctor takes care of everything. Unfortunately, if you go 50 kilometers away, I'm not talking about lighter side, don't take it literally, but the same doctor may be treatment for the vet as well as the human being. There's nothing you can do about it, right? Doctor do not want to go to those places like breast cancer. The mortality rate in some of the Maharashtra areas is 50% of detected patients. It's very huge. So early detection can save lives.
And this example of how exactly in previous speaker you heard is reinforcement learning, machine learning, feature learning, all these things combined.
And backbone for GenAI is getting the quality data first, machine learning based categorization of the data, putting it in the right buckets, then deep learning, and then you can collate all that data together. That's the meaning when we apply it to the healthcare domain.
And the clinical applications like drug choice, chemotherapy, or surgery,
How do we make a decision? This is nothing but decision making in clinical, which is called clinical decision support system from the FDA terminology, and worldwide doctors know about this. And if you took it the same thing from the pharma companies, this is called evidence-based management for clinical trials. So one and the same thing, just looking at the problems are very different angle. And just quickly want to introduce my company. So we work on this clinical decision support softwares. We are a pure software company. We analyze X-ray, CT scan, mammography, etc. Mostly medical imaging data.
and again this is an example of detection of the breast cancer. Then
Mostly we are using 2 or 3 modalities here. So here in medical world, the modality is type of instrument we use. It is contrast and CT scan, or it could be breast MRI, it could be 3D tomosynthesis, like that.
so we use most of this.
And the model depends on what kind of problem you want to solve. The underlying, whether you want to use it on GPU or whether you want to use on CPU. The CPU is multi-core models, and there is a GPU is many-core models. In many-core models, you get the high level of parallelism, but the thread local storage is not available. So you cannot transfer the data between the threads. That's a basic principle of parallelism. And this is outsourced model. It's not the software outsourcing, but the compute is outsourced to the GPUs. And so depending on what problem you want to solve, level of parallelism you want to achieve, that's the reason you can select CPU or GPU. So that is called data science architecture. Another important point I want to highlight here is
so you need to point with the sir here.
yeah. Yeah, so another important point is even doctors do ask why you are saying how you train the model, why you are saying the person is having say breast cancer, how you are saying that the lesion is detected as cancer. We don't know what it is cancer or not. We detect the lesions. The confirmative test will decide, the clinician will decide with the clinical correlations. You don't get the clinical correlation, it is indicative diagnosis, right? And then you build another model on top of it to come up with a confirmation of that decision, take the further action. For example, like I say, this X-ray is having tuberculosis. Tuberculosis is not detected like that in normal world, but in AI world, we can tell that this person is having tuberculosis because there are cavities and other stuff we have found. And that's the reason we say this is a tuberculosis. Now, doctor who asked like, how do you train the model, how much data you use? To be blunt, that is none of their business, right? Their business is how I prove my point. Whether I tested it, if you are doing MS, after say MBBS, you want to write a thesis. Thesis you want to compare, say you have to study something like at least 5,000 patients. On 5,000 patients, feed into the system and you have to prove that what doctor is saying and what AI is saying, it is coming close to say 90-95%. Doctor's accuracy, doctor, I'd say medical accuracy in many ways. In case of accuracy of tuberculosis in India, 30% is accuracy. 30%. People get missing because they send us put-up test. It comes after 3 weeks, the patient is missing, even if it is detected positive in TB. That's how one of the reasons TB is growing. India's major problem is related to multi-drug resistant TB. So, coming back to this topic, the explainable AI is not about telling how the model is trained. It's about how exactly it helps the people. So, we have to answer that. Because again, how much data I use, I have to put that thing in ICMR, do that. I have used right set of data. Okay.
So how do I train my model and how much data I use?
In medical world, the data itself is not very easy to get access. But on the contrary, some of the data like chest or breast cancer or some of the other organs, not all organs, for some of the diseases, maybe we may use 1 million data point that is called brute force learning. Brute force learning, that is statistical learning, unsupervised learning. That data is available in the universities and KGO and everything. Then the middle one, that's what I wanted to just highlight, don't want to cover too much of that. Is semi-supervised learning is a label data. Nowadays, they also use some label data to train your model. That is like start biasing the model. And third one is supervised learning, which is most expensive and most complicated. You have to really closely work with those doctors and surgeons and maybe as good as you want to get their brains dumped into the system. So the system starts behaving like a doctor, but still it is assistant. It is stupid way to say like if you are using a stethoscope will take over your brain. No, never. Stethoscope is extension to ear. So all these deep learning, GenAI techniques are extension to the brain, right?
So now what is it? Does it detection, reconstruction, segmentation, classification, and
several long list. Maybe I just put 4 because I found this image good.
when you go to NVIDIA,
Again, they are offering the same thing. Again, don't get confused. What they are saying is their technology, they always try to sell to us like startups. Okay, this is ready. When we say, okay, what is ready? This is this is just the indicative stuff, what is possible to use with their toolchain. And this generator adversarial and other networks are good when there is lesser data available, good for the imaging kind of data. So remember, these are not images, this is imaging data in medical world. So you can generate this kind of data and train the models, and then there are various ways to get from start to end. There are very in-depth examples from the medical world. Yeah, so maybe 5 years down the line, we are going to wait for natural intelligence.
the application to radiology, and this is again various ways to handle it,
CNN, RNN, various models are used
to analyze. This is again manual segmentation and the tumors absence, non-absence, and finding the edema, finding the tumors. These are very, very different in-depth topics. But remember the bottom line, fully supervised, right? Mixed supervised and mixed supervised. So again, very quickly going through this,
it is possible to eradicate some diseases like this. You have to run really after that. You need to use some tools like diabetes. Maybe the diabetes capital is India. Therefore, India doesn't like it. But what else?
so various ways to handle it, input, analyze, output. So
All these things, if you feed it to a GenAI model, it will be much better to create that kind of networks.
So if people said, can you do diabetes, type 2 diabetes on
Deep learning or chest PA, chest X-ray. Yes, it is possible. This is a research not done by me, somebody else. This was not known in medical world. So what is unknown, that is also you can find like this, right? It is possible.
As I said, some unfortunate, because in the medical world, people get disease, they die, and visiting the hospital may not be any reason for the technology folks. And you have to accept that there is a challenge in case of cancer, and there are various ways, right from the medical imaging to the histopathology. These are the cells, right? Magnified cells. So AI-based detection on the breast cancer screening and as well as 3D tomosynthesis for staging, so that's what we are also doing. And this is a complete chart of how exactly it works, various aspects of it, image-based analysis and segmentation, diagnosis, staging, monitoring of the treatment. So this is what all even we do, and there are a few more companies they are also working on this. I think once this technology stabilizes, then definitely we see a lot of benefits to the women, and this I think this will be a great tool for women empowerment. So as I said, tuberculosis is a huge problem, and Western countries they don't have TB, so but most of the funds to do the research it's coming from America. It's so simple. Japan has completely eradicated. They took 20 years. Now the Prime Minister says they will do it by 2025. And that's where the opportunity is. But the problem is severe, right? It's 500-year-old disease. So this is a typical workflow. We feed the into the system and analyze and create the report. So for people who are coming from purely as a user, they should understand the value, what they are getting. So this is some of the stuff we are also learning, that purely technology, telling deep learning doesn't work. You have to tell in simple language. So I think this is no longer a funny thing, because I think Google is calling back, and this kind of tools are already available now. So AI has the ability to think and do like humans much faster, can crunch very large amount of data and create that kind of environment for you to get to the insights of the problem. And just to quickly on the summarize, we did come to a long way to come to the stage where we are able to speak, where we are able to talk to the customers. Building this kind of deep technology is a huge work. And as Gaurav said, yes, we started in Pune, and not in Semi-Supervised, somewhere else. So, and then we want to move to, I already have a small team in UK and US, so I'm just trying to expand. And just want to conclude here, so in the last few months I traveled a lot, and multiple places in India, because they called me for conference, speeches and whatnot. So amazing food, and you can enjoy the stuff. So I wanted to create a presentation which is lighter, but slightly it is on the technical slide. So, but I would like to stop here, and thanks again for.
Thank you so much, sir. Any questions for?
My question is, we understand that there is a concept in clinical sciences called the natural history of the disease. It starts, it progresses, there is certain advanced stage, etc. And we know that there is a possibility of changing it by doing certain things. That is one. And secondly, some part of it may become symptomatic, or it may not become symptomatic. For example, aging. We call aging as asymptomatic, but if you have symptoms with age, it is called as degeneration. Now, I just wanted to ask one single question. In all these models, when you process the image, is the same person seen at various points of time to see the progression or regression or same level of disease in that particular patient? And in the long term, longitudinal study is done here, or we only see episodic sort of images?
So the longitudinal studies, we actually as technology company don't do it. We just use the retrospective data. We don't need to wait for 20 years for the data. Whosoever has kept it well, that is useful. Many hospitals in the world also, they are not able to keep that data because there is no way they can keep it. As simple as that. And government, these people can tell you how difficult it is to build a medical database, right? And to answer your question, another way is the way
you as a doctor, you as a radiologist, you as a surgeon, you see image or imaging thing on the screen, as well as when you cut the organ and see that stuff. Computer doesn't see anything like that. I will give you one simple example, and because not from healthcare domain, other domain. You know this stone throwing miscreants, right? And there is an algorithm to track the facial recognition algorithm, right? And that used to detect the human face with just 6 features, 6 lines. There's the chin line, the eye line, that's it. Right? Now to fool that, somebody posted it directly on Twitter how to fool that algorithm. It's not 4K image, right? It's not 4K image. It's about only 6 lines. 6 lines. And then you put a toothpaste like this, and you put the polish like this, you can fool the algorithm. Again, they went back to the whiteboard, fix that algorithm. Now I just put a complete mask here, my eyes, they are able to detect. The enhancement is there. With 6 or 8 lines, they are able to tell like this is my sibling. Okay. So, I don't know what exactly they do, but they will be able to draw certain intelligence very concluding. But they already used it. They already used it in multiple cases, and legally they have provided that. So my point here is AI doesn't see what human beings see. It's totally different way of seeing the things. It will just feed into you. If you like it, you say, hey, I like it, I want to use it. Or say, hey, no, this is a useless thing. Hey, go, get lost. That's what we also hear every day. They like it, they, oh man, this is something I want to use. And the prognosis is a different thing. We cannot do prognosis, we don't have that much data available. So the prognosis is basically predictive and prescriptive analytics, right? So not prescriptive, doesn't take decision on its own, but somehow tell the future. Somehow tell the future how much time it may take to cure that disease. So we cannot wait for 20 years. Everything as a company, as a technology players, Google, Microsoft, they have got you in next 2 years. Another way of technology will come and it will kill.
My point there was, it seems that the technology companies try to compress a lot, saying that you can do it very fast and come out with predictions. So how far is it correlated with the actual progression of the problem, of the disease?
We closely work, already working with almost 10 hospitals. We are using their data for labor data, semi-supervised learning, in case of cases, supervised learning. We closely work with multiple doctors. Okay. So it is very, very strict the way you work, rather than the way we work. We don't work like that. I'm coming from very large capital markets background, capital market technology background. So we don't work like that. Software is created very differently. It is mapped to your needs. So you feel like, oh, this is for me.
I think we can also add this point, maybe Vatsal can also add his perspective. So can we have a kind of algorithm where with data science which the algorithm has been trained, can we provide some context to it? Like sir mentioned that can I have, for example, if it is my exam, can I provide my own 3 set of Excel which I've taken in the last past period, and then can I somehow generate insights on that data? So maybe Vatsal you can cover that.
No, certainly we can do that, but as Ajit already mentioned, it's about availability of that data, how it's kept, is it really regular? Because I know even smartphones have the face detection right now, but it doesn't recognize the front of the face directly. Taking a photo every day, it's still not working. So theoretically it's possible, but I'd like to quote my professor, Dr. Ronald Given, who is kind of a statistician of the century. And he says a human can identify somebody in a bus from the back of their head on a rainy night, but software or computer vision still from the front of the face, a direct photo is not able to identify. There are still leaps and bounds, but as Ajit mentioned, it's all about technology compressing those features, identifying what can work. It doesn't work the human way. It has its own way. We are trying to fit it as much as humans think. But maybe it has a different way of understanding, a different way of interpretation. All you want to do is augment doctors in achieving that rather than kind of replacing or solving the problem. It's an extension to what we are doing.
Great, thanks so much. Somebody has a question? Any other questions for Ajit sir? Okay, thank you so much, sir.
Thanks.
Okay, sir. I think we have guest who is our next speaker. He is I know he and John Hopkins, as well as he has more than 15 years of experience in providing developing solutions for pharma and medical industry. He has more than 30 plus patents on his name. So, and recently, like he has been, sorry, he has received with an recognition BW Healthcare 40 under 40. So, big round of applause for Vatsal.
Thank you, Agarwal. And I'll kind of cover the gap between what Arpan mentioned and what Alisa presented. So trying to bridge the gap between what technology can do and where we are stuck and what could be an alternative for that. And the topic of my presentation is accessible but unavailable healthcare data for AI. So now my first question is, when you're talking about computer vision, what does come to your mind with respect to healthcare data? What do you guys think of healthcare data that computer vision can help? Any examples? What is medical data? What is healthcare data that computer vision can help? Anything else? That's kind of the first one. This is what we count as healthcare data that computer vision can help with. But surprisingly, this does not constitute 20% of the entire data. There is 80% other data set which usually we kind of ignore as a technical or data science community. So there are so many patient reports, which are also mentioned. They are all textual. There is so much literature. From what I know, entire Vatsal office of Novartis, which is practically a small city, the entire basement is full of files. Last 50 years of experiment that they have done, all the research they have done, is kept in those files. Last 5 years or 7 years, they have taken an initiative to digitalize all of that and try to make it useful. Still, they are not able to use it very much, but the efforts are ongoing. So that's the gap I see, or we have seen, identified several years ago. How do we convert that data into its usable form? But before we go into that, is it useful? So I think partially that got covered in the previous conversation, but it is about 70% of the data is held as PDFs and scans. Every radiological image that we are trying to process through through computer vision has a corresponding text file, a patient report, a doctor's report, a pathologist report, all of that is existing. So what we are thinking or we have been pursuing is not only get the medical images, but get the corresponding textual images, even if it is not followed on a map, it is dirty, it is kept in a garage with 40,000 patient records. If we can just get the text out and somehow correlate with the corresponding image, we have a label data. Because in computer vision, the biggest problem, which Ajit also highlighted, is for supervised learning, you need at least 10,000 images. For unsupervised, close to 1,000,000. But through this, even if not 100% accurate, 90-95% accurate images can get a sample of 1 million relatively easily if you are able to match the two and do that in-house. So that's what we have been trying to achieve. And another thing, with all those scientific experiments happening, I have personally been to the Vatsal office several times of Novartis, and the same story holds true for PPD, from LLP, for BMS, and all of those. They do not have access to their own data. Because all of those text files are archived somewhere, there are certain orders to get access to those data sets, and then those experiments are kind of lost. 20 years later, somebody comes up with a great idea, let's do this experiment, which is already made 20 years ago. Nobody knows about it. So there is a positivity bias in the entire literature that is out there. Only the positive results get reported. Only the successful patient treatments are being reported. All the negative tests which have been encouraged So the idea is we can pull all of that data out, index it, make it searchable, connect the dots across, and then it's a gold mine of data with the AI industry having. But among the data scientists, it's always they have a concept, can't OCR do it. It's just extracting the text out of it. So OCR is optical character recognition. It can identify the characters written on a page. But if you see this image or that image first, in that image there is yes text. But the text has a lot of context which an OCR would give. For example, there are headings. So every piece of text belongs to a certain heading. It's not like you can read left to right and everything is okay. Because that text means under that heading what that is contextualized as. Similarly, there is a small chart there. Now, no OCR or nobody reads the chart, and probably anybody knowledgeable in the field would practically look at the chart first and read everything else later. There is a lot of information. It's said that an image is worth 1,000 words, and OCR, a lot of technologies miss out on the chart and focus only on the text. Then there are several other images, several sections, how the page is kind of laid out. But coming to this next image, there are a lot of checkboxes. Now these checkboxes have to be understood by the machine. So what is tick, what is cross, and people are slightly liberal in using different symbols. What do you mean if somebody has a tick and then they cross it? You have to realize what that means. Lot of these things have patient consent at the bottom. So there is a signature place, you just have to sign there. But the closest we could come so far is if there is a blue mark around somewhere that area, we consider that consent. Because nobody can match the signature, especially on this kind of bad quality image which you usually get. But these are the things which our technology had to handle. We are not 100% there, but that is what we have been striving for. The next part is how we did it. Now, this is where I will take some more of a time. I couldn't detail each part because of privacy concerns. But first, starting with orientation correction. Now, when you scan documents, I think you must have all gotten copies of Aadhaar card, and every time somebody needs to take a copy of it. But those scans are hardly ever straight. We assume in all computer vision that the images are absolutely straight lines. But a lot of times it's 180 degrees inverted or 90 degrees inverted, which is still the easier part of it. But a lot of times there are 5 degrees, 7 degrees rotated. And when you start reading it, it comes up returns blank. So first is orientation correction. So we have filed for certain on papers and so on that we are writing about it. How to identify what orientation the page has. So first thing is correcting the orientation of the page itself. Then is the main content extractor. What that is, every paper practically has a header, a footer, a page number, and a lot of other things which is not in the content. If you are taking a patient report, almost every time on the top would be the lab or the clinic, address, phone number, at the bottom, contact details, doctor's name, and so on. You don't want that information, we are using the medical information to extract the main content. The first patent is on that part. Then there is relevant pages and documents. So once you start downloading those papers, then you will find out there is some billing information, there is some NOC, there is some other kind of documents which have nothing to do with medical domain. So you can filter those down, the documents, and then comes the key part, layout analysis. So we analyze how the page is structured. What is your reading order? Usually we know it's left to right, but a lot of pages as humans, practically all the documents that have ever been created are for human consumption. Nobody ever thought, I am going to create this document so machine can read it. That's only the wish of our us data scientists. But the world doesn't work that way, at least till now. Hopefully everybody converts to JSON very soon. But till that is happening, we are converting or understanding the layouts of the page. How this page is supposed to be read out. There is a chart somewhere, which line does that chart correspond to? If something is in bold or in red, as humans we immediately correct this is more important. But machine needs to understand it. For as Arpan was showing, it's just pixels. It doesn't know this is more important, so you have to identify what are the most important parts of the pages. So that's the thing that we did, and then each of them have to be independently analyzed. For text, we created a hyper OCR. OCR is just any optical character. As we have hypertext, HTML is hypertext, which is enriched, color, bold, fonts, and all of those. Same way we are reading the page, we are not just getting the text, but also the context or the importance of that text placed in the content. So that is what we are highlighting. So it's a hypertext that we are kind of extracting there. Then the font changed from first line to second line. First line was all italic, second line was all bold. So there is probably some different meaning. We cannot do case by case, so we let machine identify there is some importance attached to some differentiation in font. And then we have a life science language processing. Again, a building on that is everybody is kind of dealing with natural language processing. Natural language is what is written in newspapers. Even social media doesn't follow natural language for the most part. And what we have observed and what we believe always is a person skilled in the field can read the text, but a layman cannot. Even Times of India articles, when my parents read, they read it in a completely different light. Okay, everybody associates things with the word they can understand, but a medical doctor, a life scientist, a biochemistry person can understand those things in a different context. Then why do we believe a natural language person can do that? That's why when we are reading a paper, it has to be life sciences contextualized. So we have developed a complete stack of NLP altogether for life sciences. And that is what we use to contextualize the text that we get from these documents. That it's talking about an ICD code, and this ICD code corresponds to this disease. So that is why the lab test mentioned has to be around that and not something completely different. Then similarly tables. So table is everybody tells me it's a solved problem, but I haven't found a solution so far. So every document has tables, and again, there is as data scientists, we believe every table has to have boundaries. But I have received at least 50% of the tables from my team, my medical team. Can you get this table out and there is no boundary? It assumes that these are structured in a particular table and we have to get them. Then there are tables that are spanning multiple pages. When I get my medical report, the page starts on page 1, the report starts, and the same table continues on the second page. There are 3 columns, usually the test name, the value that you have, and the minimum and maximum. And this table is very obvious, and probably every patient has this format, but still there is no standard way to get the information. So that's what we have been doing about the tables, extracting them and converting them again to usable form. And the last one is graphs and charts. And I was taking that graph. It's still very difficult to interpret what the graph is trying to say. What is the information in that graph? So the first thing, very obvious thing that we realized is, if we can just connect the line mentioning the graph, we can get half the context of the graph. And then the legend and the axes are enough. We are not trying to resolve the problem that is mentioned in the graph, only that what it is talking about and present it to a doctor or to an expert, and they can understand what it is. Our job should be to search and empower and not to solve for what it is supposed to be. And then finally putting all of this together in a JSON format. So for those of you who don't understand, JSON is currently the easiest format to explain to a machine. So it explains everything and you can nest it in any level of depth. And that's what we do is convert that into a JSON format that any machine can understand, and then we can build any number of models. Now the question comes, all of this is good, but then these days the data is still not available. How do I train with it? So even if we get all of that information, how do we train with it? These are also mentioned it. Semi-supervised approach is one of them. The beauty of semi-supervised approach is you have a large amount of unlabeled data. You are just getting the data, let machine understand the context. Let machine understand what this domain is about. So if it sees HER2 positive 200 times in a breast cancer report, it doesn't have to understand anything. Just that these two things come together. Similarly, there are so many examples. If EGFR is coming with kidney, it's probably talking about the kidney function rather than another EGFR which is epidemic growth factor receptor. So we just let the machine understand with unlabeled data. And as of today, there is no shortage of unlabeled data in the public domain. You can let machine understand what these words, what these things just mean. And then you quietly add a small flavor of label. So you add 20, 100, 500 samples, and then let it classify. Now that I understand the language, what are these documents saying? You do one iteration, it learns something, you identify the patterns, and you do second iteration. Give 200 new examples with a specific pattern that's missing or it's lacking, and then you don't need 10,000 samples ever, probably 1,000 samples to your question. So it's not necessary that we absolutely need 10,000 or a million document. That has been a concern for everyone. And like that, we don't get that kind of data. But with this few iterations of small samples, you can achieve good accuracy. And that's what even the quality control can help us. Because in the beginning, as Arthur mentioned, we can look at few samples saying this is good, this image is good. But how many images can we look at? A few hundred at max. And then after that we know, oh, the data set was not so good, we got 100 images that were okay. This way we can pass on 200, see how much model learned, pass another 200, see the data set is not so good, look at another one. You can keep on learning and can have intermittent milestones defining where do you want to stop, because AI will never hit 100%, at least for next 20 years, more or less no. But this way we can define our own threshold what is good enough for us. Then there is another way which is called self-supervised. So I don't know how many of you have heard about this, but ChatGPT is a self-supervised one. So nobody is telling us what is right, what is wrong. We are just passing in information after information. And sometimes you kind of mask a word. You tell it to predict what the word here will be. You have read thousands of pages or millions of pages. Based on that, what would be the word here? Just guess the word. And when it says this word is, say, the or was or something, then we tell it, no, this word is this, or you are correct, this is the correct word. So this is self-supervised. We don't need a separate set. We just ask it to say, look at everything and predict the one which we already know about. We're not going to tell you. You predict the word here. And if you're correct, it's a positive reinforcement. If you say it's wrong, tell it the correct word, it learns. So that's how ChatGPT has been working. But even in there is kind of a belief developed in the entire world community that ChatGPT can do everything. So to many people, like people are thinking, I can just put in my symptoms and I'll get an answer. You don't get that. That's a safety in place. But it is like fire or knife. These are tools. You should know how to use this tool. And if a patient comes to you and says that I have read this and this, then it's the same thing. If you're using a gas stove, you have to know how to use it. Otherwise, people say this is bad or this is the best one I have to solve my problem. So it's a tool and it has to be placed correctly. ChatGPT cannot solve, I would say, 80-90% of healthcare problems, but it can help in contextualizing this data, cleaning up this data, identifying the right parts, but it's not enough to convert it to a JSON. I think I've tried several times, but it can solve many of the intermediate problems. So we are working towards building a multimodal foundation model, which is like text, images, charts, speeches, everything. Let it understand what all of this means. Not saying it solve any problem. Just learn how the world works. What are different images? And then hiding certain things. We know this is a cat, but we won't tell you. You identify this is a cat or not, and we will correct you. So just learn the entire model, and then for each problem, we train this to say, okay, now here are 200 patient samples. You predict, we will correct you. Now you know how to solve this problem. So that's what Innoplexus has been working on, and that's pretty much the end of my presentation. So happy to take any questions.
is for Vatsal.
So, after listening to this informative talk from you and this, I had one question to both of you. So, as we have found this technical background, and this healthcare is another sector domain. So, how do you keep up with it, knowledge with this program?
I would say it's like everything else you just read. So same way we are training the machine, the same way we train everything. Just read about it, what is happening, how things are, what it all means. So you may not become a doctor, but you'll start understanding the language and the terms. That's my side, if you like that.
So on the lighter side, we learned the hard way. I almost made about 125 doctors now. And my first consulting assignment was Japanese, so they gave me the Japanese way of doing things. I have to read everything. I talk to the doctor, what he said, what are his views, what is his credential, everything I have to record. 35 people have paid for it. After that, I stopped. And now, some of my teams, just looking at the chest x-ray, and, hey, I see the cavity there. Oh, like this is, I said, you're not a doctor, you're not supposed to talk like that. You tell what system is reading. Hey, system is reading that. So I just said, that's a hard way to learn. But this is a harder domain than the programming and digitization work. Unless you know the domain, either you pick up or you move the 50 is domain, 50% is domain person. For example, now you want to work with a surgeon, 50% time or brain is surgeon's brain, only 50% is your. Out of that, the AI brain is maybe 20%, 30% is productization, making the API, putting on the cloud, how exactly they will consume that kind. I think it is a hard way, but there is no other choice. This is everywhere, this is the same way. ChatGPT has zero meaning when it comes to enterprise or application area, unless you pick up that domain. Pick up the domain, fantastic. Otherwise, in 10th grader, my kid is able to use ChatGPT to write the letters. And you are doing the same thing, nobody will pay for it. That's the challenge. So somewhere you have to break that. It's a hard way, it takes long time. And as I told, I came from the capital market background. I was writing data analytics in GBM for HSBC. Almost 15 years working with Wall Street customers. So no way I have to take that. You have to do it. Because I think that this decade will be completely healthcare decade. That's what people are telling. So I don't know.
Any other question?
The question is very basic, but I want to learn, that's why I'm asking you. So if there is any page in which with hyper OCR you mentioned, you have scanned it, and that page includes text, it includes graph, and it includes some image. So how is differentiation? Because each need different pre-processing steps. So how is differentiation?
So how we do it is, there's a step before that, atmosphere is the layout parser. So that's what I was mentioning. If you do, so that layout parser first identifies this page is divided into 2 columns, 3 rows, this part is here and so on. So it takes the image out, separates it, takes the table out, separates all the content, and identifies these are the text blocks. This is the reading order for these text blocks. And then applies the OCR or the hyper OCR to get the text out and connect them. So it's not essentially not running over images whatsoever. For charts, etc., it's running out the section of the charts, but not the text aspects.
So there are related libraries for this layout analysis.
There are libraries. There is YOLO 5, I think, does a little bit of that. There is Layout LM and other technologies that are providing that. But they are not providing the end-to-end support. So for layout parser, we use parts of them or we improvise on them and then connect all the dots to come up with this kind of a complete parser.
Thank you.
I have a very simple question. Is this all related to English language or do you also take Chinese and Japanese and all that Korean?
Yeah, so that's why I have put a small comment here in the language detection. So right now it can handle all the Latin languages. So English, Japanese, or sorry, English, Spanish, French, all the Latin languages are covered. In theory, this is compatible with everything else, but we haven't done so far Hindi or Chinese or Japanese. There was a project that came for Bulgarian and for Hebrew. So we were able to test all cases, so that which proved to us that this is compatible, but we haven't done the last test on it.
Okay, I think that's. Thank you so much, Vatsal, for this insightful talk. Next, we have Mr. Vishal Kumar. He is an IT company. He is CEO and CEO of Relive Technology. And he has been awarded with his technology history under 35. And he has settled more than 20 launches and medical equipment. So all the engineers out there, you need to learn a lot from there. Thank you so much. All to you.
Thank you, Adarsh. Thank you, everyone, for having me here. So, before I start with some disclaimers, healthcare for me is like medical elephant. I've been in this field for the last 15 years as a technologist, and it's very difficult to decode. I'm not a clinician, I'm not a data scientist, I'm not a medical imaging expert. I'm an old school medical devices person. I love the physical aspects of things, building medical devices that go inside the body, treat, etc. etc. So consider me as one of those blind men trying to explain healthcare along with all of you. Yeah, so here the purpose of this presentation of this talk is to just give you some glimpses of some cool problems to solve in the entire spectrum of medical imaging and healthcare devices as a whole. And pretty much the kind of things that got me excited, like let's say 10 years ago. And in order to do that, what I want to do is to just kind of create a collage across various organ types, various stages of diagnostic steps, like across the care continuum to give you that entire glimpse. And I'm not a medical doctor, so just let's go again. Okay. I just want to start with this. So this was a research assignment that I was a part of when I was still in college. It was basically a research internship at the University of Munich Hospital in Germany, where I was kind of developing novel eye-based tracking technology for a clinical neuroscience application. This was the device that we were working on at that time. The interesting thing I want to mention here was that during that 3 months period of the research internship, so this was the clinical Rosada, like the large hospital in Munich. And on this side was the lab, and on that side was the cafeteria. So every day, along with all the lab members, we used to travel from the lab to the cafeteria, crossing the large hospital in between. And me as a 20-year-old at that time, I just got so fascinated looking at the amazing equipment that the hospital had and the amazing infrastructure. But the downside was that there were hardly any patients to see. All the patients that you would find in a premier hospital in Munich would be like elderly patients. Which if you contrast to what you see in India, with dilapidated healthcare infrastructure and patients coming in a hospital like this, I was just all come back and do something in medical technology. And that's how this entire thing got started. I started my career with Philips Healthcare. Philips at that time was here in Pune itself, was developing this international X-ray scanner system. Now, this is like an elephant system that sits in a OT for orthopedic applications. But in these years of developing this X-ray system along with the team from Philips and Siemens, etc., what I learned was the entire, the art of developing the medical equipment and also the value that the equipment and its novel features bring to bring about clinical value. Now, if you see here, this system can undergo a lot of angulations, as you can see. This is one of the angulation that is possible, right? Now, this allows you to capture the image of a patient at various like points of focus, basically. If the patient is on the patient table, you can actually image the patient in various formats. Now, a lot of the problems can actually get solved if there is some innovation in the hardware itself, and you are able to actually extract data in a very different manner. This was the kind of insight that I kind of stumbled upon when I was working in the Philips like several years ago, around 10 years ago. And that got me interested, like all of this actually, this got me interested in delving deeper into medical devices. Now, touching upon the topic of today, what I've done is that I've just broken down the entire spectrum of clinical care and, and try to present some examples so that we get some idea of some interesting problems and how can we actually, as a community, advance the field of healthcare forward. Now, early stage screening. So in the first talk, we talked about how to differentiate or how to identify features for various images, etc. Now consider a scenario where there is a screening camp happening and there is patients coming in for early stage screening of their eye, basically. Now here, the kind of features that we are talking about, let's say this is diagnosis for diabetic retinopathy. And here the kind of features that we need to distinguish are things like hard exhibits, microaneurysms, blots, etc., which are extremely difficult to be even classified. Now, along with that, we have to deal with the problems of inter and intra-user variabilities. When you are actually addressing those problems in a, let's say, low middle income country or a resource poor setting, or in situations where there are a lot of patients to be treated. So those are the, so sir mentioned about the entire aspect about adding a component about everything or the human touch. Those are the factors that need to be also incorporated in our technology design, whether it be hardware or it be software or data. Now, let's say another example is this, which is cervical cancer. Again, like one of the screening methods is the imaging system called colposcopy, right? Colposcopy is basically like a magnifying telescope, so to speak. Now, there are like device innovations happening even in the space of colposcopy, where you can even have a tool like this, which is not a remotely used device, but it can actually go intelligently and image the subjects. Now here the images that you get, you have to be able to identify things like which are high grade kind of features, which are low grade kind of features. Where are the boundaries? What is the manifestation of the features that can be representative of the lesions? So these are the critical problems. Now, coming to the human side of things, the patient can come with mucus on the surface. The patient can come with blood stains. Those kind of things also have to be taken care of. You can have the best imaging systems, but again, if those things are not taken care of, you will end up having a very poor quality input to start with. Then there are techniques of putting acetic acid on the surface of the cervix to clean, to also enhance the image. Okay, so then we come to differential diagnosis, like applications where differential diagnosis is important, and Ajit sir is handling some of those problems. And he also mentioned a problem that I also made. Now, this for people who are let's say, starting in the field of healthcare and just to be their interest. Now, I think I need some water. I'm a little under the weather. Yeah, so this is our lung. Now, there can be situations where, so the lung is encapsulated in a pleural cavity. Now, there can be situations where the pleural cavity gets filled with fluid. Yeah. So the fluid could be, let's say, air, or it could be some liquid. When it is air, it is pneumothorax. When it is some liquid, it is diffusion. Now, how do you differentiate? For example, in the case of pneumothorax, you will find very sharp osmotic angles. Like these are the angles which are like present in a normal anatomy, where you will not have fluid filled in the sacs here, right? But in this case, you will actually find uh, spots representative of pneumothorax like this. But in this case, you can see there's some kind of a blunting of those angles. So it is not as sharp as this one. So the point I'm trying to make here is that for any technologies, it is also important to understand the underlying physics of the things happening to be able to design better algorithms, better technologies, etc. Okay, another case is for differential diagnosis is when you have, let's say, in the case of ovarian cancer or ovarian diseases, you have a cyst taking place. Now, cysts can be of various types, right? Now, the idea is to be able to identify between a cyst and a mass. How do you do that? Now, they could be, the cyst could be made up of several structures, several intracellular structures. There could be several irregularities, there could be several differences in the vascularities of the cyst. Those kind of things, and when you kind of classify using the image processing or computer vision tools that we are going to develop, you can differentiate them to these different types of disease conditions. Now, as Sir also mentioned, it is very important to correlate all of these conditions with the presented clinical symptoms of the patient. Otherwise, you can just end up solving a good technical problem, be happy, but it will not actually relate to anything. Going to diagnostic staging. Again, just to give an idea to the audience who may not be from the healthcare field. Now, this is also a very crucial application where computer vision comes handy, which is staging of the disease itself. Now, some of you might be familiar. So, TNM staging. TNM staging is a method used in for tumor classification basically. Then T stands for T represents the extent of penetration of the tumor, and N stands for the number of nodes it has affected, and M stands for the extent of metastasis. Basically, this here is image of the bowel, and there's a layers of tissue of the bowel which is made up of, and so for example, so when you get a CT scan done, you'll find this kind of a classification done, like a TNF staging. Now that helps in the treatment planning for the patient, basically, and also in staging of the disease. Again, for people who are interested to learn more on this, for example, stage 3 is typically when one of the nodes also get affected. And there's like a very comprehensive method of doing this. It's just a very preliminary view. Again, you use imaging modalities in tandem. You use CT, you use a PET scan to really classify and then plan the different regimen for the patient. Again, so here this is like a PET scan done on the patient. So when I was working on all these projects, I came to learn about this thing that human actually gets metastasized either through the vascular system or the lymphatic system. Now these kind of insights help you in some way in my field when you're designing a kind of a device, let's say for blocking a particular vessel or removing the clot from a particular artery or in your field, where you can actually make use of these insights into developing more intelligent systems. Okay, interventional diagnostics. Now, these are areas where, these are the areas which are already in kind of under development, and we need a lot of work to be done locally in India as well. Now, here what I'm trying to make, the point I'm trying to make is that we also need a lot of work to be done for situations such as these, where imaging is used interventionally. Now, here we are going to find even aspiration. This is the case of like a thyroid cancer where tissue has to be, or sample has to be taken out from the thyroid nodules. Now, you can imagine that this location is at a place where it's like a network of, like a entire highway of activity in the near region. How do you aspirate the sample, the fluid or the tissue from a situation like that without intent, without harming any critical organ? Those are the kind of things that we have to answer when developing our systems and technologies. Now, in the case of breast cancer, again, there is finally aspiration happening for aspiration of cells and tissues, etc. Now, what if the sample of interest is very small? There are micro classifications. Or what if the sample of interest is at a depth wherein the sensitivity of the ultrasound images will fade? So how do you make your systems enhance? How do you make your needle enhance to be able to take care of those situations? Like for example, one example is in the case of thyroid, the previous example that I showed. A color doppler gives you the direction of flow, right, of the blood on the images. That gives the technician or the operator some idea about the anatomical landmarks to be able to be more accurate when they're performing those procedures. Now, these are some of the procedures, these are some of the, some value-added features and technologies that can be added when we are addressing problems like this. Okay, another problem in interventional diagnostics is, let's say, of polyps. Now, polyps are a very common occurrence in the human body, in the colon, etc. Now, polyps are of two types. One is something like this, which is a polyp with a stalk, which is pedunculated. The other is a polyp which is generally flat in nature. Now, these polyps are more common. The flat polyps are more common. And they are just very nasty to be identified. In fact, there is a entire classification system to classify or to categorize these polyps under these kind of manifestations to be able to decide or design the treatment plan. Now, how do we improve our imaging technologies to identify those polyps during the colonoscopy? Now, that is one part. The hardware is one part, the imaging is another part. There are other clinical aspects involved. For example, when a patient undergoes colonoscopy, the bowel has to be first pre-prepared. Now, if there are things already present in the bowel, so such things will interfere in the imaging itself. They will not be able to get a good image. Second is that there will be polyps which are hidden behind these folds. There are device innovations, technical innovations happening which actually open up, like flare up the colon walls to be able to give you a better picture of these polyps. And then you can apply your imaging algorithms and advancements. For example, in this field, there are techniques like endoscopy or NCBI imaging, which LBI imaging, which improve the diagnostic ability of the imaging modalities to identify these polyps. Okay, and then I come to pre-operative planning. This has been talked about in the previous discussions as well. Just to give you some examples here. In the case of a Caesar, let's say. So, so what is this? How does the Caesar come about? Basically, it's like a epileptogenic shock that happens, and what is it exactly? It is like an outburst of electrical activity. Now, the treatment for this is to ablate, reset, or interventionally treat. But then you need to pinpoint the exact location of the lesion which is leading to a phenomena like this. It could be dysphagia, it could be a kind of a steroid lesion. That is one part. The second part is that while in order to treat the patient for a condition like this, and if you are going intervention, there you need to be cautious of eloquent brain lesions. Like for example, what are the brain lesions that are still active, which are not dysfunctional, right? So we have to identify those and do a proper path planning to be able to reach those issues of interest for treatment purposes. Again, in the case of, let's say, liver, let's say a liver tumor is there and it has to be treated. For example, so liver tumors have this entire classification system where people have classified that what tumors can be addressed by ablation modalities, what tumors can be addressed by radiation therapy. Now, let's say if a tumor is present at a location which is at the periphery of the liver and has the potential to also affect the organ surrounding, right? So there has to be a comprehensive, a resection planning system behind it, or a pre-operative planning system to be able to even address problems like those. And you can see that this is such a complex, system to even look into. With complex vasculatures, complex molecules, organs surrounding it, etc. And then the last part is interventional therapeutics, where imaging as imaging as a technology being used for the purpose of delivering therapy as well in conjunction with other devices. And one example is that of mitral valve repair. Now, mitral valve is the valve connecting the atrium and the left atrium and left ventricle. And its purpose is to allow for one directional flow. Now, because of certain reasons, it can get swollen up, it can get prolapsed, and because of that, the functioning can get affected. Now, how do you treat that? You treat that with surgical interventions, but then you can't continue to open up the patient every time, like you do something on the valve, and then you close the patient and see the performance. You can't do that. You have to have something which is intraoperative and which helps you in improving the quality of your surgical intervention to treat the mitral valve disease. Now, so then there are techniques like transcatheter echocardiogram. So it is through the esophagus we're getting live real-time images, and from those images we're able to identify the critical features which need to be potentially operated upon. Now, these are some of the areas where the topic of our discussion, which is GPU and the processing speed and the computation capabilities, etc., need to be, can be applied. When we're talking about instant decision making, right, doing everything at rapid speed and with high level of accuracy, also incorporating, multimodality data coming from all over to help the patient in better assessing the current situation and being able to perform the right procedure. Okay, another example is that of AVM. It's an arterial venous valve condition. Now, a typical arterial venous system has to be a part of a circulation system where the veins supply the atrial blood and the arteries supply the blood. Now, in certain scenarios, what happens is that a virus like this gets created, which is a kind of which is called an arteriovenous malformation. What happens is that these kind of viruses, they have the tendency to recruit a lot of feeding arteries into them. Now, one method to solve this is to remove the virus, surgical resection of the virus. Now, if you do surgical resection of the virus, the feeding arteries will continue to be open, and hence the procedure may not be successful. So one pre-operative step is to actually block some of those feeding arteries which are supplying blood to the iris, and then do a surgical resection after some time. Now, that procedure in clinical terms is called embolization, like putting a blockage material into the feeding arteries. Now, in order to do that, there is a problem of affecting arteries which are actually supplying blood to the critical organs. For example, if you are putting a blockage to one of the vessels that is supplying, let's say if you are putting a blockage here, what will happen is that this vessel, which might be supplying blood blood flow critical organ will also get blocked. Those are the kind of decisions that need to be taken intraoperatively, where imaging modalities are again, get handy. So this is an image where the lightness was there and it was under a contrast, and here the embolic material was introduced and it was successfully achieved. The embolization was successfully achieved to block the artery feeding the lightness. And then the last part is post-operative monitoring, where again imaging modalities are handy. So here I've just taken an example of tracking, basically tracking the implant post a surgical procedure. There will be several reasons why an implant can get displaced or dislodged from the intended location. One of those reasons is bone mineral density. With age, what happens is that the bones become a little spongy in layman terms, and that makes it difficult for the medical screws to stay in place. There is degeneration, etc. Now, again, these are problems to be addressed. Like, can we intraoperatively measure bone mineral density? It is still not possible with the current technologies available. And the last example will be this, where glioblastoma multiforme, one of the most aggressive forms of cancer, brain cancer, affecting the glial cells, and so why post-operative monitoring is very important here is that this is, like as I said, since this is one of the most aggressive forms, the chances of recurrences are very high. Now, so you can monitor a patient over a period of time using MRI, using the various modalities available, etc. But then there is a condition called pseudoprogression. What happens in pseudoprogression is that once the patient is put on chemotherapy or any other treatment, there could be inflammations, there could be other factors which lead to edema in the brain parenchyma, which can also get picked up as the growth of the actual tumor. So we need to be able to differentiate between these kind of situations in an imaging modality that will be developed. And just last to conclude on these points, this has been talked about throughout this evening. Alignment with the clinical workflow is very important. Like, for example, we need to know, if you're building a piece of software, or if you're utilizing data for a particular application, you need to be sure, or you need to be actually aware of where that sits in the clinical workflow of things. Second is implementing user capabilities in using, interpreting these technologies, whether it be software or hardware. The sensitivity of information that the test or the device generates. Handling artifacts. Again, things like breathing, things like the condition of the bowel, the condition of the bladder, etc. Those kind of things need to be taken care of. Correlational clinical symptoms, of course, yes, and multimodality co-registrations. And maybe just the last image I have is, let's say laparoscopy surgery is being carried out. You have the rest of the imaging systems available and the best laparoscope available. And when you're doing electropathy and there's surgical scope, and because of the scope, the entire field of view becomes like this. So what do you do in those kind of situations? How do you improve that? It's hardware and software both. So yeah, this was like a short summary of what I wanted to share.
Any questions for consultation? Okay. Thank you so much. We can also discuss your concerns in the Q&A session. We'll have a panel discussion, but before that, we can have 5 minutes biological break. We can have water, use the washroom. By that time, we will set the stage. Okay, we'll meet exact after 5 minutes.
After the enlightening sessions, we have this panel discussion to ensure that whatever you heard in the sessions, if there are more questions around it, yes, we have tried to cover a few questions. But of course, we take questions from audience again, post our questions. The idea is, okay, whatever has been shared here, sticks in your mind. You take, when you go back, you have your brain cells working already. So, we can start. Yeah. Okay. Okay. So I'm not checking messages, I'm just checking the questions. I've been provided the list of questions which I have to ask. I have to stick to the script. So I'll start with the most generic questions, given that this is around computer vision healthcare, but the speakers have covered this already to an extent, I see, but still I'll ask for everyone's benefit. So first question is, what is the new tech or the use case in computer vision these days? So whichever area of work where you are involved, where you are working, in your area of work, around your products, your service, your sector, what is it that you see as the new thing, the new shining kid? What do you see? So we'll start on that side alphabetically.
Yeah, so I think this computer vision is a very old area. What I see in healthcare is they used to use mostly diagnostic imaging extensively, the cell-related photos, magnifications extensively. What do you think we have seen? And there are a few more possibilities if you are really interested. One of the startups I made, they are taking the oral or dental photos, and then they are able to predict the deformities and for orthodontists. This is something new, which I think doctor might be doing it, but it is completely AI driven now. And there are a few more photo applications, and the correlations related possibilities are enormous. As I said, I was working on the breast cancer related stuff. So looking at the patient, will you able to tell there is a possibility of breast cancer? So these are the enormous possibilities. Nobody has proven. The dental people are already working. There are several such examples in the Ayurveda. I have seen that application. And then it is not very easy to gather that level of data, but very good try. If you remember this, the Ayurveda channel, you will take look at your tongue as a primary thing, take color changes. So he was trying to gather the photos of the tongue, say after waking up in the afternoon, evening, post-coffee, post-lunch, and then they are able to draw some inferences. So I think the possibilities are enormous. So that's what I have noticed.
Thanks, that's really interesting to know. That is, I'll get more details from you later. What do you see? The new thing?
So I'll try to answer that question from a macro level. So the trend that I'm seeing in healthcare is a paradigm that is moving away from fee-based service that clinicians provide to more value-based care. Now, what that translates to us is that how do you create value? You create value by, let's say, minimizing complications. You're performing a particular procedure, but then you're also minimizing. You're creating value by reducing the dependence on the skills of the operator who is actually performing that procedure. Or you're sending the patient home sooner. Those kind of situations. So if we adapt our technology development and offerings, etc., to these macro trends,
probably all of us will get aligned to things being more receptive by their learning. If I could take just one thing, minimizing complications when you are actually delivering therapy to the patient is something that is very close to me in terms of the area that I want to target going forward.
Great, thanks. So, in value as a keyword. Yeah, what's it?
I think I'll add more broadly since the two have covered quite well in healthcare. And we have discussed today application in virtual reality, in like DALI code, Arthur had mentioned, and generative AI, a lot of things are happening. But I think for computer vision on a broad level, there's going to be a competition between deepfakes and detecting. So generative AI is getting good by the minute, and there would be tools coming up which have kind of started is using computer vision to detect the deepfakes, and it's kind of become a tussle between trade-off. At one step, somebody is improving it and somebody is detecting. And an example was mentioned earlier that you just put certain paint on your face and so on, and it's not able to detect. So there will be these new methods coming to counter that, and then again new. So I think next 4-5 years this is going to be an ongoing competition.
Yeah, I'll say there's always been a tussle. I would say the non-geeks, I'll say, or non-techies always used to joke that the techies first create the problem and then invent the solution. The same way, it's for the deep fakes, created the problem and now we want to solve it. So that's an interesting one. I think there's a lot of work that's happening in that area. Okay. So moving on, going specific on to healthcare and computer vision. So this is something which each one of you has touched upon a bit, but again, if you can emphasize, what's the biggest challenge in implementing computer vision tech in the healthcare setting, right, which you see today? What do you
So I think when you say computer vision or any imaging analysis, the main thing the acquisition of the data, that itself is a challenge if you really focus on the healthcare domain. Acquisition of the data, then the veracity of the data, means the truthfulness and the rationalization or correction of the data. So there are a few more companies, they are actually working on the image reconstruction or very simple to understand. I will give one very simple example. Even my 10-year-old daughter in CBSE school, she could solve that in a way. When the X-ray is fed into our system, which is slightly tilted, 5% tilt, or maybe 7% tilt. And this is usual stuff, by the way. With digital X-ray, that's okay, but otherwise, sometimes it is not correctly taken. So data acquisition is a problem. So using simple C2 package in Python, she could demonstrate this thing like, okay, the image is treated for a flower, and I have to write straighten it up. So all these primitives, and they become very important, and that is one of the biggest challenge. And the second challenge is the keeping of this imaging data because it takes so much of space. And there is no way you can, after some time, there is something called PKCS, Picture Archival and Communication System, that is the main store of medical imaging data. And that the data is available only for 5 years, because 5 years there are no computers for them. You have been working for many years. And so it's not very variable. You cannot vary, you cannot correlate. Again, you have to build the models. I think these two are the main challenges: the data acquisition and the correctness of the data. Otherwise, what exactly you build on what? The base is not strong. And so maybe the third one is the adoption because of these challenges. The judicial did not accept this. They say this is not correct, rejected completely. It's just because you fed the wrong image, the results are wrong, and you are like, you don't know what to do now. So you are already assuming that your algorithm is fed with the right and correct image. Right?
You're correct. So garbage in, garbage out, that principle always holds. In this case, we are looking at our own experience, getting the right data, and absolutely is will always remain a challenge. It is an ongoing journey, and as the data landscape itself is evolving every time, what earlier we were not interested in, now we are. Every time we will continue. What do you do, Deshpande? What do you see the challenges?
So of course, like these are like definitely the substratum of challenges in this field. But one more point I was raised in the discussion was also about how to have those annotations with the clinical relevance. So those kind of things are also missing. So let's say you have a data available as first level, you have the veracity of the data verified as available, but the relevance with the clinical manifestations of the patient across a period of time. Those kind of things also need to be added. Now, one thing, from my field of work, which is medical devices, there's another challenge actually, which is, there's no data available for certain types of new medical device innovations. For example, let's say if you are in the area of liver ablation, and if you want to build some kind of, let's say, ablation tool for treatment of liver tumors. Now, the liver is a tissue which gets deformed when you are actually performing the procedure on it, right? Now, what happens? How do you, first of all, measure that deformation to be able to make the step towards providing a better quality ablation treatment for the patient, so that you ensure that the resection margins are within the limits that you wanted to achieve, etc. So now there is no data available to even build something like this. It has to start with some kind of data models, correlated systems, just to get a guess of what is happening, and then you test out of animals and then you test out of humans. That's another level of challenge actually, and hence why investments in medical devices.
Agreed. And this is again, so even we have been looking at maybe a few companies, and we have been evaluating companies and vision. That's how we see it, that our own experience and what we have seen, that difference really comes in when the winner will be the one who will be able to get the best data set, training data set ultimately, and then something on which, and that becomes the goal really that they have, because rest everything is moving, but if you are able to get in the right kind of experts to get the right kind of data set, and then that solves a lot of the problems down the value chain. Yeah, what's it?
I have 2 points. I agree to this point, the point mentioned, and one is obviously computational power. Now it is getting more and more easier, but still, as you mentioned, it's humongous cost just on the infrastructure and to try out different models and so on. So computational power is still a hindrance. It's coming down very fast, and hopefully it's able to solve, but the complexity of the problem is still too large. But more importantly, I believe I'll take an example of other industries, and that holds true everywhere for AI, is the reluctance to identify the right use case and to convince everyone that it works. I'll take the example of first cricket. So, Empire decision review system, everybody is critical of that. Now people are starting to accept, and they say AI should be 100%. If Empire is making 50% of the mistakes, it's still acceptable because you have somebody to blame. Same with cars. The decision in self-driving cars has been, if there is an accident, who will you hang? It's not Elon Musk. It's not the head of Google. Who will you hang? So it's the same thing. Even if someday, not today, but someday, if computer vision is able to do better than a doctor, Still, the question remains the ethical aspect of it. Who do you hold responsible for somebody's life? That's, I think, the discussion has been going on for years now and it will continue. But that is definitely a big hindrance for applying this technology in real life.
Okay, given that, yeah, from looking at healthcare and for wider adoption of AI in healthcare, that indeed is a major issue because that's where, in the end, if that's how, again, the joke is like if the government or the regulators can't find anyone responsible for it, they know people are going to hold them responsible, and that is what they don't want. So they also want that, okay, we found that don't catch hold of our net. That's how it is. Okay. So from challenges, moving to the solution. We have to build this thing, we have to get the solutions in place. What are the skill set that you see that is required to work on such CV use cases, and how do you see that one can develop these skills? So people who are aspiring to leverage computer vision, people who are aspiring to get into this field, what do you see the kind of skill set that they should have, and how can they develop these?
So I think the CV here is computer vision, right? Not that will be not resume, right? Hopefully not. So so we are right from the college days, and I'm already out of college for 30 years. In my time, we went to the campus to enjoy, learn from others and somehow study. Now, I get so many calls every year when they pass out with, yeah, they look at the credential of the professor, they study. I don't know, maybe they'll ask like what 12 marks and then how much you score, etc. So, I don't know what exactly they're expecting from this working college and IT Bombay and everything. And then that's how they compare. But why exactly you need all that? You need a guru. I'm people to mirror or you need a guru to tell, but so many tools are available. Best tool to learn Python is any cases from your side. I just took a random example just to learn Python. How this Python is being used for everything. The best tool to use Python. No. YouTube. Maybe anything else. Just YouTube videos. Yeah. So ChatGPT is like your open book. You don't need to think how to plug into the whole system. What systems are available and what problem you're trying to solve. And I think problem solving ability for the young people that will help them. And for senior people like old age people like me and several people here going today. I think the first thing is ability to unlearn. If you are coming from that object-oriented programming and old software background, you will be never able to pick up the cognitive sciences, unlearn, start from start. And I think it is so easy, it's so intuitive. And the tools, etc., it's immaterial every 6 months. Can tell better what is the frequency of the tools they create nowadays. Any month you going within 6 months, who will create what? All that feeling you get, obviously you get. What is that progression? How do you pick up the beginning of this campus in the 1940? November there was no campus. And they were asking if you have an exception skill like changing. Okay, then boy studying they have a skill like that. But I said, okay. In December somebody came and little bit of relaxation. Otherwise, you have to wait until that. I don't.
No, I agree to it. Unlearning is the most important skill because things are changing so fast, and then if you develop this mindset of that, okay, this is how I should be doing things, I think that will prove to be a bigger challenge than anything. Yeah. Over to you, Ishan.
Yeah, so I think the one thing I've learned through all my experiences is that first you have to, the most important skill to have is to actually be humble and just acknowledge that you just know this thing, just a tiny bit of the entire landscape thing that you're trying to take a change in the world and everything. And that will make you receptive to feedback, to insights, perspectives of several people. And this is one field where you need to have a perspective coming from a healthcare worker on the ground to, let's say, what a CEO of Medtronic is talking about the next, next wave in medical technology sector. So you have to be receptive to all of that. So that's the first part. The second part is to inculcate this habit of asking questions. Now, in our education system, since childhood, we have been trained to always solve for X. And that's how we have learned things, right? Solve for X. But we have never learned how to formulate X. And just to give you an example, so take two physics books, analytic and Epsilon. Epsilon will start with a problem, like Indian mindset of, I'm moving is something hard. But then, if you let's say see a problem from analysis, you'll actually get to that formulation of the problem itself from the narration of the problem, right? So that's one of the important when we are actually trying to work on solve problems. The third thing is to be, as Sir also mentioned, is to it's kind of being a knowledge sponge, so to speak. Like take feedback, insights, knowledge from everywhere possible, channel that, apply that, and then see what best is possible.
So, I really like that part to be very knowledge sponge. I think that is something you end up realizing that it doesn't matter whatever you have done, you're always going to get it still. So, never it is going to be enough. Yeah, Vatsal.
I continue from that point itself, very much agree. And I think I mentioned this during one of the questions as well, is read. I think it's very true in general. So, just picking up things wherever, whatever new you hear, just read about it. And that's works for me, and I think it works for many people. If you have any question, any topic, anything that you hear, just read about it. You will not understand every word of it, you don't need to. But every time you read something, you have four more new terms, four new concepts, also read about it. So if you continue to read, there is automatically no need for going anything specific. And there's too much content, not just YouTube or Wikipedia or GitHub, or there's so much out there these days. We are in the best era for learning. So my first advice is definitely read as much as you can, and it doesn't stop at any age. So not like we are out of college and we are done with studying, it's the continuous habit of reading. And the second point that I believe is more of learning the basics. So whether it's Python or in general programming, whether it's anything like mathematics or computer vision, people start directly with deep learning, and I believe that's a mistake as technology is changing. 5 years down the line, I believe nobody would be asking about deep learning or computer vision as a technology. There would be new buzzwords. But if you know mathematics, if you know linear algebra, if you know machine learning basics, where the machine learning is coming from, how deep learning has evolved, then you don't need to ask the question about what do I learn today, because you know how it's evolution and you're reading, then you can connect the dots pretty good. That would be my advice for computer vision, but practically for everything else.
Thank you. Thank you also. So I think this we have covered a lot. What do we need? I just add to it. In fact, drawing on what all three of you said, it's I find I think overall what needs to there is. The vision needs to be there even at a personal level that you are aspiring to, as Nishant said, it's not solve for X, but yeah, okay, you need to do only this. No? You need to look beyond, you need to see in a longer term, what is the trajectory that you want to take and what is that vision for yourself that you want to set out for. Otherwise, just as Vatsal said, I want to learn this, to learn that. That's never going to help much because I'll probably borrow again from Ajit when he said on the unlearning part. I think the most important skill again would be even how to learn. Right? That would be the most important part because if you learn how to learn, then you're set to win because that is the only thing that you need to do. On this way, you will need to keep learning at a frenetic pace. Everything is coming in. But if you have mastered the art how to learn, then I think you'll be able to go well. Cool. So with that, I think we end. So thank you, panelists and speakers, and thank you, audience. It's been great. Oh, question?
One question, maybe on it's a very different thing that you people ask. What is it is, I mean, you are doing some work, you hire engineers, you know the kind of pressures you can make. So, is there a way we can design some course? We can design some course for 3 months, 4 months, 6 months, so that these guys, when they come up with it, slightly more useful or they understand some basics. Like you said, connecting the dots, I mean, उसको भी बता दें कि machine learning क्या होता है, deep learning क्या होता है, neural network क्या होता है, something so. मतलब we give them some quick जड़ी बूटी in 3 months, you know, something. मतलब they can be slightly more useful than the way they are. Because I am thinking of doing this for a long time. I did this for very successful for VLSI in 2000 and it was very successful. If you have any visuals and लगता नहीं है data analysis very successful.
Thank you. Yeah, any takes on that?
I can take a stab at it. So I would say, as Gaurav was saying, the art of learning itself. So in that 3-month course, rather than having standard things played back, because we were discussing technologies change every few months. Might take 18 months later, everything changes entirely. So that course could be something like where students can themselves find the latest technology. They can make an application on that. It can be a very simple one. It doesn't need to be going to NASA or something like that. It's a simple technology. They pick up a topic they like. They ask questions to their professors, to their teachers, to their mentors. They develop something and they know how to develop, how to learn that technology. That would be an exceptional course. Because I have heard that IITs have also started adopting electives and more project kind of works, and that kind of I like very much. So maybe something like that, because no matter what you teach, how great that is, 2 years down the line, it may not be that relevant.
I just what you said. In 2000, I had an institute where I used to teach VLSI. You can see my logo. कंपनी का लोगो था, we teach you how to learn. बहुत सारे भी हमारा लोगो था, we teach you how to learn.
On a slightly different note, you have such a great background. So the problem as a your country, not as a country, and what I see as a country, what we are lacking is this cross-functional teams or cross-functional knowledge sharing. So what I can say is we consider because growth is the biggest threat for any establishment. And how do we detect it? These people in security, whatever, Indian security forces, they know how to well down what they see. Okay. But the problem is they don't know how to utilize rest of the current existing available technologies. And that's why the cross-learning is important. And second point is many of these countries, for example, our country has established great relationship with this new newly formed maybe post USSR era, Pakistan country, Uzbekistan, etc. They are very poor in medical education for some reason, as opposed to Ukraine is leading in the medical education. Our boys go there. Pakistan country they have, so they somehow we are able to export this education to them, medical education, and some tourism coming back and totally. These are some of the larger opportunities where these technologies can do a lot of breakthrough innovations. And for the young people, that's part of our job. I was with TCS for almost a decade. He gave me 50 young people and said, okay, you might have to make them real. That's the technology they use in services business. And I don't know, somehow creating if success criteria is there, you are successful. That's it. What you teach it doesn't matter. So all this skill I think we learn during our career. But I think the other areas where we are lacking behind and we don't have any skills, just because they are not talking to each other. And there are several such examples, and I'm not expert, you can read those some of the articles where the country is really lagging behind in case of your India found such a big reserve of lithium. We have no idea how to extract it, how to productize it. The lithium reserves are there, you again need to get the foreign companies to come here, take a heavy cut, and we don't have any control over how much they will produce and how much they will not extract. So I think somewhere that training part is, you are absolutely right. I don't have any answer, I just give some examples.
We can have some initiative on training. I don't know what is it, where is it, but I think that training thing has to be.
So just one point to add to that. So I myself underwent a 3 months internship program at Pune, which I mentioned about, and that was the thing that changed my life forever. Because I came back and did everything in healthcare after that. And the reason was that in the lab that I was hired as an intern, summer research intern in Munich, was a place where engineers, physicists, clinicians, all were actually working, all were sharing insights and ideas at a daily level. And me as a 20-year-old intern at that time, I was just learning all of these layers of doing research, writing publications around the government without it being a part of the agenda, right? So this is one part. In applying that to healthcare in the current scenario that we're talking about, I think sending a young person to an OT and getting that person experience firsthand the pressures of decision making in a split second time, and being able to revive the patient, resuscitate the patient, etc. I don't think any further motivation will require that person beyond that. If a person is there and sees that thing at least once. And just one more point I want to add on that was, so after my graduation, I was hired with Philips Healthcare, at Philips Healthcare. Now, one of the managers at Philips told me that because you're coming from IT, you hired you at a position of like a design engineer and all that. Ideally, you should have been hired under the services. Like you should be hired as a service engineer. You should be able to go to the places where systems break down, to see what are the problems, and then you get escalated to the level of a design engineer. And I think that makes sense. But unfortunately, because of being an IT, can't get started as a service engineer. So yeah.
Okay, great. I think that's one point, exposure, and I think that is what actually IIT. I always say that IITs are a platform to provide exposure in the end. Nothing. It's not that people there coming, we can debate about talent, etc. But I think the biggest difference has been exposure. And what you said, at Munich, that's what essentially you got exposed to that. I think that's something which can be looked upon. How we can get able to expose the young people to that kind of an environment. That will definitely make things more. Thanks. There's one more.
So I just wanted to add regarding the training and the other things. As we are talking about products where we are, making products using computer vision or AI for clinicians or healthcare providers. We do see that there are government initiatives by ICMRs and other government agencies where they give continuous learning programs for the clinicians. So why don't government takes a proposal ahead, or some proposal where in this continuous training, the clinicians are made aware of how a data can be rightly, formatted, stored or something like this, so that the clinicians also become a part of understanding how data is important and what value it has if it is processed or kept properly to get the right insights and how it can drive making right decisions. So, such kind of collaborations, it can happen, I think so it would be a good initiative. That's what I think.
Thanks. That's an interesting. And this again, I have already seen this happen in Europe. Here, maybe I can say that conversation itself has not started. So definitely, I think before we expect government to do something on it, I think then we need to have that conversation getting started first so that people understand because it's always the path to action, I believe, is always at least here in this setup where we are. Anything which people ask for will definitely happen. Anything which government just decides to bulldoze through or just says, "No, you do it," probably will die. So I think the better way is that if we make people aware why it is important and how it is going to add value to it, to them or to the program, that will be the better way. Thanks. Any more questions?
Yeah, I have a question. As I learned, the biggest thing, I'll speak loud here. मेरी आवाज सुनाई दे रही है? Yes. So, मेरा question बहुत simple है. हम सबको पता है जो भी कंप्यूटर विजन या एआई में काम करके डेटा मिलता नहीं है, टैगिंग या नोटेशन करने के लिए लोग नहीं मिलते हैं जो उस लेवल के हैं, उनमें ही लड़ाई हो जाती है, नहीं है, वो नहीं है, स्टेट वन स्टेट उस पे भी लड़ाई हो जाती है. तो what can be the solution for this? हम लोगों ने सबने फिर तो मार दिया कि डेटा नहीं है, डेटा नहीं है, डेटा नहीं है. बट डेटा में फिर कॉन्फिडेंशियलिटी लग जाती है, अलग-अलग प्रकार के रेगुलेशंस आ जाते हैं कि हॉस्पिटल कैन नॉट शेयर डेटा, दिस डेटा, दैट डेटा. हाउ डू वी मेक इट पॉसिबल? बिकॉज़ मुझे लगता है ये सबसे बड़ा $1 बिलियन स्टार्टअप बन सकता है जो सिर्फ डेटा प्रोवाइड कर रहा है एआई वाली जनता, क्योंकि ये जनता तो बहुत आगे है, डेटा वाली जनता नहीं है. So what do you guys think? सबसे अच्छा क्या हो सकता है?
So I think we have been dealing with these. I would say startup is probably not the solution for it. The startup cannot, no $1 billion startup cannot do this. But for data, in my slides also I covered a little bit how we can connect the existing data. Now there are better EHR and EMR systems coming up, data being registered in a better manner. We can extract those much better than what we could get from a regional cancer center in India from the 1990s. That data was really difficult to convert. But now that data is coming up, and there are more and more startups looking into data from various angles, and even government is allowing the use of data in certain ways. So with DPDP new act coming up, it will certainly turn into a bill very soon. It allows industry to use that data in a certain way. So together with that, the concept of federated learning is kind of binding all of them together. So far the requirement is all data has to be at one place. All annotated, all cleaned up, all at one place, high quality data and then you. But we have tackled the data cleaning problem. Quality is not every time a bad thing. Because in deep learning algorithms, bad quality data acts as a regularizer and it avoids overfitting. And from connectivity perspective, federated learning can run across 2000 hospitals or clinic data in isolation. And all of that is combined. That is likely a way ahead, but yeah, the guess is, my guess is as good as anybody else. This is what I see is connecting.
I'll just add that on this. Since we are part of these programs, I can speak about it. Like the Asia's largest health data program is all set to be rolled out in India very soon. And Innoplexus is the company which is developing the entire platform. But in there, the entire push is on how to get this data and in a usable form and to make it available or rather license it, where in industry or even in academia, anybody who wants to get access to this data in an ethical, legal, and compliant manner without worrying about anything can do that. So, and this is a program where ultimately entire country's population is going to be screened at some point of time. So yes, I think it's starting, and as you said, yeah, I agree with Vatsal that it's less likely that any $1 million startup will be able to, because at some or the other way, it is regulations. I think it needs to come via government only, where what government has, Indian government has done marvelously, really well that they have been able to create the concept of digital public good. I think open data, digital public good, that is a better way, and in fact, Europe, US, everybody is agreeing now. They are looking to Bharat with hope that yeah, okay, India has been able to do that. It means that's the way to go. So I think digital public good is a better way to solve it. Yeah, you want to add?
Just for that, this is for data platforms. This is one of the overall initiatives that haven't seen real data like I don't know really use cases, but the government is building aggressively.
Yeah.
The challenge why I mentioned it, we were designing something about knee surgeries, especially the arthroplastic, knee replacement. All the data that I could get was foreign data, not Indian data. Anatomy of a German person is very different than an Indian knee. And if you are designing your AI for a German knee, your implants will be larger, relatively larger. So that was the challenge. Nobody was. I mean, we were not even able to 3D print करके. It was not getting. The prediction was wrong. The 3D print was also wrong. Nobody was ready to give us the data.
Yeah. So just my a few thoughts on that is that maybe we just change the problem and solve a different problem where data is available and wait for critical mass to happen and come and arrive that people get more receptive towards generating more data, which is better index, etc. That is definitely, for example, in one area like let's say gastroenterology, some might also say Japan is way ahead in terms of their gastroenterology programs. Why? Because they have national level screening happening at regular intervals for the entire population. That means that they have access to data, that means they have access to more information possible in software, in hardware, etc. etc. So maybe those kind of niche areas can be picked up first and then wait. And then as we talk in medical images, which is like others have multimodality kind of approach. Even this will require a multimodality kind of a strategy that you include, let's say, an ICT course in medical schools as well, which makes them more sensitive towards data and its value at a college level itself. And then eventually in 10 years period of time, probably we'll all have data for all the innovations that we want to pursue.
Thanks. And just one question on the eye.
Just add to this one point. For my recent tracking of this data, very high level, I will just mention that so the top two countries who are able to manage the data very well is US and China. China has an excellent network they have formed in the country with research, academia, and that's the reason there are several Chinese companies that are making a lot of money in this AI business. And you will see more. Another thing is surprising is something like Israel, whose population is less than a crore. Many Israeli companies are able to get this implants and measurements. You see, all these companies are by default Israeli companies. How they do it, that you have to do. And from the planning and vision perspective, I guess 2 years back, 3 years back, NHS started this more than $1 billion program. They want to connect this research, academia, pharma, for betterment of treatment, patient care, everything. They do like implants, medical devices. That is to be completely driven by the medical imaging and diagnostic side. Very ambitious program there, and they are US, UK, biobank, several projects they have launched. And from the India perspective, many companies do approach us saying that do you want to buy my data, I have so much big data and all that stuff. It's absolutely no point in touching the data because the data is not cleansed.
it's all random data, and what exactly you do with it? They want to actually, they don't want to help us in the sense, they want to sell it to us. Sell it to us. So they say, no, it's not complete, no use. Unless you build some targeted models, what will you use? These images are blurred images, not properly captured, no annotation, you don't know what is the patient age. Just like that, they are lying there. They feel that they have they have a lot of data. That data is not useful. So I think that's why a lot of work at the startup or any company, including Google, they are trying to do it through startups only at a smaller company. And the main aim is the government who can connect these dots. It's a huge initiative. I think Persistent also tried for the mobile bank project in genomics, I guess. So several efforts are going on. I'm not saying perfectly is not doing several efforts. But you are absolutely right. Getting the right set of data is a big struggle. Big struggle.
Thank you. Thank you. Yeah, we'll just take the last question.
Okay, thank you. So my question is, when you say you don't have a data, the thing is, when you see AI or there is two aspects to it. One says you have preventive healthcare, one is you are doing diagnostics and going into more details. So which one is more? Because for preventive healthcare, probably you can bypass few layers of the data and you don't need the information about liver. Probably despite this segregation, if there are ability to predict and do a preventive health checkup and things like that. Why do you need the condition of the liver or things like that? So if you are able to give the outcome, which is more important rather than doing the diagnostic. And there are companies who are getting data using gadgets and other things and trying to correlate that data, which is easily available and much more screened as compared to what detailed information you are looking for. And it may go in that direction that preventive healthcare is better than diagnosing the real problem or some problem.
I like that actually. That is a topic close to my heart. Everybody knows actually prevention is better than cure. And the civilization which we represent in Ayurveda is very much there. It's like you should not even get to that stage where you need to be cured. Right? But unfortunately, in the world where we are, and the current economical environment, there is no money in prevention. Absolutely zero. Right? So it's not about whether that problem can be solved. It is okay. Who do you want to solve the problem? Who will pay? It's as simple as that. Why people want the diagnostic problem to be solved? Because there is a payer. Somebody is going to pay. It's a simple thing, right? You go and pay because you have the X-ray image, you have the CT, MRI, whatever, right? You pay. But if I tell you that I will just मैं आपकी नाड़ी चेक करूँगा और आपको डेली बताऊँगा कि हाँ आप ठीक हैं या नहीं, will you pay? Unfortunately, we don't have that setup today, wherein you say yes, I will pay, I am ready to do that. There simply is no money. Right? That is why there is no action, practically no action that is happening in Medicaid. What you mentioned about devices that the data is available easily, I think part of the answer Ajit already gave. It may look like that since we have these devices, the data is so much as data is there, it's easily available. First, it's not easily available. They are ready to sell that data. Right? And even then, even if like say you are ready to buy the data, unfortunately it's not usable at a level wherein any company would want it. Right? Like what is that cleans? The data needs to be clean, data needs to be in a format which really is useful for me. It needs to be annotated, right? It needs to be in a way that in my model I can use it for my model. Otherwise, the only company which has been able to crack that code on its own is Apple. Right? Because when Apple came out with the smartwatch, they were very clear why they are doing it. They were building the healthcare. Right? But everybody else who got there, They unfortunately thought, oh yeah, Apple is selling a watch, I'll also sell a watch. Okay? And that is where the quality of data which Apple actually gets from that device and is able to work on that is far better than anything that you will find in any of the companies. Right? That is where they made a mistake. Because everybody thought that I'm selling a watch. Right? They forgot it's actually about the data. Only Apple thought about it. That yeah, why they are giving the watch to get that data. Sorry, longer answer.
I'll just add a point here. Even companies like Ancestry.com, Heritage, 123, and Me, these guys tried polygenic risk score, and there are many more companies we have been talking to. Even Apple, they are collecting the data in the hope that after 15 years, this data might start to make sense. Because for preventive healthcare, you need to have an incident. So once heart attack is much more prevalent, so they are now able to predict that much better. But still only a few minutes to a couple of hours before that, not really days. So you need 15 years of longitudinal data for at least 1 billion people or 700 million people to predict what might happen. And what are they measuring is just blood pressure, heartbeats to some extent, and so on. Many of these are not even implicated in many other diseases. So that's why for preventive health, you need to measure everything for everybody for 1 million patients for several years to start with. That's also part of the problem, but yeah, if the money is there, nobody will invest.
Okay. Yeah, we close that here. We have run out of the time. Others, over to you.
Thanks, PJ, and all the participants and the guests for this. Before we leave, we just have one thing to do.
Last thing, please give us 5 minutes.
With just our guests.